Right. So, what is this unit 3? Structure of matter. Matter means what? What's the matter? It doesn't matter. It's not the matter here. It's English matter. What is chemistry matter? Matter means starting with M. Matter starts with M. M. Mango. MASS. 50% correct, 50% correct. Matter means simply materials, things, and materials are in 3 physical states. Can you remember what? Solid state, liquid state, gaseous state, and they are made up of atoms, particles, that is matter. And according to definition, like you said, matter has MASS, mass or mass, and matter occupies, takes, needs space also, right. So, we are going to study about a structure of solids, liquids, gases making atoms, right. Let us go through this dude and see what are we going to complete in part 1. Page number 1 is about matter and energy classification, and we talk about atoms there. Page number 2, what is inside atom? Subatomic particles, going to discuss many things. And finally, on page 2, models to describe the structure of atom, earlier models, old models describing what atom is, what atom has, what it looks like, old models. Then page 3, the real lesson unit starting here, atomic number, mass number. You need these two up to A levels and beyond A levels also, atomic number, mass number. Isotopes. Page 4, main topic is electronic configuration. Page 5, come and see, main topic is modern periodic table. Page 5, about it. Page 7, noble gases, and the main thing is patterns in periodic table. Patterns in periodic table. In other classes, including this Saturday class, we are going to start patterns in periodic table. See, we have to come to that, and we have to cover unit 2 physics past papers also today. Can no? I think we can. But 6 pages not that simple. Page 7 is the page for Saturday class. So that's why I wanted to do class today from 8 to 4:45. But you all will leave the class. Hari, I class if I keep 8 to 4:45. So I said okay, 8 to 2. Natang I class you want to come what? 8 to 4:45. Right. Patterns in periodic table, page 7 and page 8. First ionization energy, page 7 and 8. One pattern. Next pattern, page 9. Put there. Electronegativity, page 10 also, electronegativity. These two patterns we are going to draw in the class, you and me together. I want to train your hands to draw this, that's why, right. Electronegativity, first ionization energy. Then page number 9 and 10 last one, metallic properties. 11, acidic, basic, amphoteric nature of oxides of metals, right. So, these are what we cover in part 1. Then you get part 2. Part 2 starts with metals. Metal sodium, metal magnesium, metal aluminum, metal copper, we discussed there with their reactions with air, water, dilute acids, steam, nearby. Then we start non-metals like nitrogen, oxygen, carbon, sulfur. They are basic things, non-metals. Then we come to something called valency. We talk about writing chemical formulae, and there are many past paper questions are there, right. We do all to get a training for term test and O levels, right. It takes some time, but that's why it takes long time for me to cover a particular unit. I am doing many past paper questions, which is essential, and school is not doing, I think. Hurry, right. So, structure of matter, part 1 is about this. Okay. Before introducing these things, I want to do basic part in page 1. Matter and energy. Matter means what? Energies are what? Can you read these two lines and think what to write there? Can you read this and plan what to write? Right, matter, substances with blank and occupy blank. Words come into your head? Yes, substances with a MASS, mass or mass, right there, MASS, and occupy you can come here. Right. SPACE, occupy space. Right. Come on, be little active in the morning. Still sleeping, still dreaming. Science world. Right. So one last time, matter, substances with MASS, mass or mass, and occupy SPACE, space. Okay, right. So you know matter is made up of atoms, no? So atoms have some mass and atoms need some space. Therefore matter has a mass or mass and occupy space. Energies. In this world, other than solid, liquid, gaseous things, that means other than matter, there are some other no word. I can't say some other things because they are not things. If they are things, they should be solid or liquid or gas. So there are some other, I have to use the word energies. There are some energies. Energies means energies. They are not solid, they are not liquid, they are not gases. Because they are not made up of atoms. If they are not made up of atoms, they are made up of what? You have to come to grade 11, unit 4. If you come to grade 11, unit 4 waves, you will learn that energies are made up of electric fields and magnetic fields traveling together. Little advanced. Grade 11, they are made up of electric fields and magnetic fields. They are not made up of atoms. You know, can air come through that glass? Can water come through that glass? Can solids? Can't come through the glass, but can break the glass and can come. Can't come through the glass. Why? Air, liquids, solids need the space. Glass is not giving any space for them to go. But can't light come? Of course light can come. Can't sounds come? Sounds can come. Heat can come. Ultraviolet rays, X-rays, gamma rays can come. Why? They are not made up of atoms. They don't need any space. They can travel even when there is no space. Got it? Hari? Solids, liquids, gases වලට වීදුරුවක් through එන්න බෑ. එන්න ඉඩ දෙන්නේ නැහැ වීදුරුව. Energies වලට එන්න පුළුවන්. ඇයි? ඉඩක් ඕනේ නැහැ. Hari? Got the difference? Right. So energies. Those, that's why we use the word those. We can't say things. Those that do not have a right MASS, do not have a mass, and do not occupy space. Do not occupy space. So these are the two main differences between matter and energies. Then classification. Classification of matter on physical nature and chemical composition. Classification of matter. Girls can come to this side also. We have not put here girls only. We have not put here boys only. But boys can't come to this side, but girls can come to this side. Okay. Right there. Classification of matter on physical nature and chemical composition. I don't like this word physical nature. Physical nature is not enough. It is not good actually. Matter is classified as, you know, solids, liquids, gases, and these are called physical states of matter. but our textbook is using the word physical nature. So we take it that way, but actually these are tute එක ගැහුව පොළොවේ නේ tute එක ගැහුවද පොළොවේ ඔච්චරම තරහයිද matter එක නේ හරි හරි එහෙනම් once again solids liquids gases are states of matter, but our book has given nature, physical nature. It's okay, we take it that way, but what's the correct word? Physical state, right? Physical state, not physical nature. Physical nature means like what is the color, rough or smooth, large or small. Physical state means solid, liquid and gaseous state, right? So classification of matter on physical nature, actually physical state and chemical composition, right? Matter according to physical nature there are three states: solid state, liquid state, gaseous state, but we write solid, liquid, gas. Solid, liquid, gas, there are three types. Then according to chemical composition we are going to separate matter into two, according to chemical composition into two, right? Left hand one again divided into two, yes or no? Right hand side one also again divided into two. At the end of left hand side one you get iron, oxygen, O2. Shall we write it? There is a printing mistake. Iron inside brackets FeOK. Next one OXYGEN inside brackets O2 O2 inside bracket. Next one copper inside brackets what? Capital C simple U, Cu, copper. Cube from Cu. And what is this? Nitrogen, nitrogen, right there, nitrogen, right. Now finally we get iron, oxygen, copper, nitrogen. Tell me a name for iron, oxygen, copper, nitrogen. Not only that, but also calcium, sulfur, phosphorus, gold, silver. Yeah, starting with E. E. Elements. So left hand side last division is blank is elements. Last blank on left hand side corner වම් පැත්තේ blanks වල පල්ලෙහාම එක්කෙන right above iron you should write elements, right. Then we go to its other side, water H2O, carbon dioxide CO2. These are molecules තමයි, yes they are molecules, but I need another one word starting with C. What's it? Copper? No. Canteen can't go now. Compounds, okay, right. So water, carbon dioxide, compounds. Singaling mooladravya සංයෝග, English science, chemistry, elements and compounds. Okay, right, compounds. So now can you give me a word for, but don't say loud, others should think. Elements and compounds together are called what? Don't say loud, I want others also to think. Elements, compounds together what? Starting with P. What? Pure substances. So write for them up here, pure substances. P-U-R-E, pure substances. Dimutu. අපේ ඊළඟ සැරේ කැමරා එක පෙළියක් දෙකක් පස්සට ගමු. Pure substances, P-U-R-E, pure substances. You got your friends there. Pure substances, right. Now there is a big doubt for some. Elements are pure. Why are elements pure? Oxygen element has only oxygen atoms. Carbon element has only carbon atoms. Aluminium element has only, wake up, only aluminium atoms. Sure, pure. How can we say H2O pure? How can we say CO2 pure? We can see H2O has hydrogen, oxygen, no. Carbon dioxide has carbon, oxygen, no. How do we say that they are pure? How can we say CO2 pure? It looks like carbon is there, oxygen is there. H2O, pure. It looks like hydrogen is there, oxygen is there. How do we say pure? Are they pure? This doubt is with some students. How can we say compounds are pure? Now it is like this. Say, sometimes we see when we like walk, one girl and boy walking very close together. What do people say? Good things about them? No. They scold them. Banino, chick munderna, right? Why? Not pure. Not pure. Right? But one day they get married and then they walk. People say same thing. Chick still walking. No. Now they can do anything. Now they can do anything. Anywhere they can go. Anything they can do. Now okay. Why okay now? Now pure. Before that, not pure. So what's there between them now? There's a legal bond. So legal bond makes them pure. Can go anywhere now. Can do anything now. No issue. Right? When your mother and father walking together, people say like, chick, they are going. No, now they can go anywhere, they can do anything, now pure. Legal bond. Like that. Carbon dioxide, water, all the compounds have legal bonds, not legal bonds, chemical bonds between atoms. Because of having chemical bonds, they have become one thing now. One thing. Now, mother and father like one thing, two persons but one thing. Like that, carbon, oxygen, hydrogen, oxygen bound together. One thing, water, carbon dioxide, pure. Got it? So, all the compounds are in this world, remember, pure. Why? Atoms have chemical bonds making them one thing. One thing is pure, no? One thing is pure. So, water is pure, carbon dioxide is pure, any chemical compound is pure. Okay? No more doubts. Even though you can see capital C, capital H, capital O, one thing bound together, pure. Right. So, elements are pure substances, compounds are pure substances. Okay, right. Then if they are pure substances, what is the right hand side? Non-pure substances. Don't write non-pure. Non-pure substances have a name starting with M. Mango. No. What is it? Mixtures. So, right hand side one, mixtures. Pure substances, mixtures. Now, there are two types of mixtures. You know this from grade 6, 7. When we mix things together, if they mix very well, after mixing, we can't identify even what we mix together. Why? Nicely mixed together. Everything, everywhere is same. Nicely they are getting mixed together. Right? They get together, they stay together, uniform everywhere, throughout it. It is a homogeneous or zygous? Genius. There's another word coming, homozygous later. Homogeneous mixture, but when you write homogeneous, be careful, there are 2-3 ways of writing homogeneous. We write according to our syllabus, homogeneous. Example, if we dissolve salt in water, sugar in water, can we see salt particles, dissolved salt particles? No. Sugar particles? No. Why? They are making a homogeneous mixture. If we dissolve some soil in water, can we see soil particles? Yes, we can see. Heterogeneous mixture. If you take some wheat flour and dissolve in water, can't you see wheat particles, flour particles here and there? Can see. It's a heterogeneous mixture. Sorry. If you grind chalk into powder, can you mix with water? Can. Can't you see chalk particles? Can. Heterogeneous. Okay. This way there are two types of mixtures, homogeneous, heterogeneous. In homogeneous mixtures, everything everywhere is uniform, right? And we say grade 11 unit 3. Grade 11 unit 3 is mixtures. Grade 11 unit 3 is mixtures. Everything about mixtures you can find there. It says in homogeneous mixtures, components cannot be identified separately, homogeneous. But heterogeneous mixtures, components can be distinguished. We can see that component, this component in heterogeneous mixtures. But homogeneous, no. Everything everywhere is uniform. So I am giving you very few examples. I removed some weak examples which are in textbook. I didn't add here, but I added from grade 11 unit 3 some good examples to this one. Okay, so textbook has given some simple examples which we used in grade 6 7. I removed. I added from grade 11 because our next year is grade 11. So good ne අර පොඩි කාලේ ඉගෙන ගත්තේ වයින් කරා ඉගෙන ගන්න තියෙනවා පොඩ්ඩක් එකක් දෙකක් දැම්මා. Right, that's why my examples are different to your textbook examples, not all, very few. Right, so mixtures, left hand side one, salt solution, sugar solution, and I added, you can see font is different, alcohol solution. These are homogeneous mixtures. You know, after mixing alcohol with water, can people find that alcohol has been mixed by looking at it? No. Maybe by smell can, there's a very bad smell, hurry alcohol, but by looking at it can't see. That's why sometimes girls, ladies come for parties, people mix alcohol with soft drinks like Coca-Cola, Fanta, fruit juice and give. After drinking, others can get to know that alcohol was there and alcohol is forming a homogeneous mixture. Can't identify by looking. Okay, alcohol. So be careful, be careful. Right. So homogeneous mixture. Spellings I am going to spell HOMO, HOMO, GENEOUS, GENEOUS. Don't write GENUS. It's not our spellings. We write GENEOUS. Right. Homogeneous mixtures. Then right hand side should be heterogeneous mixtures. HETEROGENEOUS. Heterogeneous mixtures. Examples: carbon dioxide, calcium carbonate. Carbon dioxide, it's actually grade 11. Carbon dioxide and hot water, heterogeneous. Carbon dioxide and cold water, homogeneous. Grade 11 unit 3 I didn't take. Calcium carbonate plus water. Where is calcium carbonate? Chalk is calcium carbonate. Egg shell is calcium carbonate. Seashells, corals, limestone, calcium carbonate. Can you dissolve in water? None of them. But can't you mix? Can mix. Then mixture is heterogeneous. If we can dissolve, mixture is homogeneous. If we can't dissolve, but we can mix, heterogeneous. Right. Calcium carbonate water, wheat flour and water, pang piti, tirungu piti, watura. But we can dissolve wheat flour in water very well now. Yeah, you can dissolve very well, but you dissolve and keep somewhere. Come after 2-3 hours and see. Wheat flour has gone down again. Deposited. That means it's a heterogeneous mixture. Right. Completed our classification. So this classification can come, put one red star. You have to know this classification. Here and there, term test, O level can ask you to fill. Panning ලියනවනේ වෙන වෙලාවක දැම්ම ලියවන හරි වැඩේ ඉවරයි. දැම්ම ලියවනම් හරි. Hari. Now building unit of matter, that means all the solids, all the liquids, all the gases. You know what is the building unit of matter? Starting with A. Apple, no. Atom. ATOM, right there. What is the building unit or structural unit of matter? ATOM. ATOM, atom. Right. Let's talk about it. Atom. The structure of an atom. You know structure of atom. You have heard. It's okay. Once again look at this one. First of all, I should tell you that this right hand side diagram which is showing you atom is wrong. Very few things are wrong there. Why do we use a wrong diagram here? You know, when we teach how to draw a man, how to draw a woman, how to draw a human, you know how small babies draw, first they draw like this, මෙහෙම කරලානේ අඳින්නේ. අත් දෙකයි කකුල් දෙකයි ඈත් කරා ඇඟිලි ටිකක් එහෙමනේ අඳින්නේ. Later මෙහෙම වෙලා various other things come to the body. Ne? So, first we need a simple one to understand, then we can make it complete. Got it? There are very few mistakes in this, because someone can criticize. There is a small mistake here. Still you do not know the mistake even, but one day you will see this is a wrong diagram. No, that is why I told you. Okay, so look at this right hand side diagram. You can see there are some rings like things. These rings like things are called energy levels or shells. Actually, there is nothing like that. They are paths. When we draw our solar system, we draw lines like this to show this is the path of the orbit of the Earth. Ne? This is the orbit of the Jupiter. We draw like that. But actually, are there paths? No. Like that, in atom, there are paths shown like this and shown like this. These are called energy levels or shells. In these energy levels, there are very fastly moving particle type called electrons. So, electrons are moving around the atom like our planets are going, not exactly like that, but like that. Okay. So, these lines are called what? You can see in the diagram, energy levels, shells. And negatively charged particles are moving in these, what do we call them? Electrons. Okay. In the first diagram also you can see shells and these X showing electrons. Sometimes we use X for electrons, X never, cross for electrons, sometimes we use dots for electrons, sometimes we put simple E, sometimes we put negative sign electrons, right. Then when we go in, there is a middle part. This middle part is made by some balls. Some are positive, they are protons. So, this middle part is called nucleus. Nucleus has two types of particles. One is positively charged protons and the next type has no charge. They are neutral. They are called neutrons. And protons, neutrons, when we together, nucleus is made by them. Okay. So, this nucleus is small. It has positively charged protons, no charge neutrons, right. Around the nucleus, what are there? Moving electrons in energy levels shells. According to O level, only this much. But other than electrons, protons and neutrons, atoms have some other subatomic particles, mesons, neutrinos, positrons, you do not know even, but know that there are some more. Okay? For us, this much is enough. Now, left hand side diagram, same, nucleus containing protons and neutrons and shells have electrons, right. So, to give you an idea about this, I am going to describe something which is not in our O-level syllabus, this one, something which is not in our syllabus. What is this? Okay, try to understand. This is an experiment conducted by a great scientist, Rutherford, Ernest Rutherford. Sometimes we call him Lord Rutherford, right. He conducted this activity. This is called gold foil experiment, to identify, to study what atom is, what is there inside the atom. He conducted this activity. Activity basically for your level, I told you it is out of syllabus, but just try to get an idea by listening. He used alpha particle emitting source here. Some positively charged particles called alpha particles are emitted by this source. He covered it using something like lead, so that alpha particles can't come out from it, and there was a small hole. Through that hole alpha particles could come out. So, this one is a lead block box. Hurry. They have damage here in this diagram for us to see what is inside, otherwise it was not damaged here, it was fully covered, right. And there was a small hole. Through this hole positively charged alpha particles came out, and he placed a very thin, extremely thin gold foil in the path of alpha particles. He wanted to see whether alpha particles can go through this foil of gold or can't go. He wanted to study about atoms, and it is said that he used 1 atom thickness, 1 atom thick gold foil. Is it possible to make 1 atom thick? Very difficult, ne? but say he used very thin gold foil, that means there were few atoms making the foil when we consider its thickness, right. And he kept a glowing screen behind it. Nowadays we have digital screen, but he didn't have digital screens that time. So, detecting a screen means there is a screen, and if alpha particles came to this screen was glowing. Alpha particles වල වැදුනොත් screen එකේ දිලිසීමක් ඇති වෙන්න තමයි හැදුවේ. And he observed what happened, and by observing this he found many things about atom. It is said that most of these alpha particles, like in the upper diagram, went through the atom, went through the gold foil straight without any issue. Most of the particles could go through gold foil without any issue. What should be the conclusion? Most of the space in an atom is empty, nothing. If there is something, can particles go? No, there is nothing. So, most of the space of an atom is empty. Second one, very few particles came back, returned back, very few particles. Why? Large atom, no, atom is very small, but if atom is very large, there is something very small in the center. What do we call it? Nucleus. So, most of the space is empty, that is why most of the particles went. Very few particles came back. Why? There is something solid at the center, very small, it is nucleus. And last observation, few particles, some particles, positively charged particles, this way, look at my hands, got deviated in large angles, coming and they are getting deviated. Positively charged particles are pushed away by this one. How can positively charged particles pushed by this one? Yeah, possible. If these charges are positive, this one can push it, this one also if positive. This one also is if positive, these positive charges can be repelled by it. So, he concluded that this nucleus is positively charged. That is why positive particles are repelled by it, deviated by it. You know, north pole and north pole of magnet, we can never bring close, they push each other. South pole also push each other, like that. Positively charged particles are, or alpha particles are deviated by positive charges in the nucleus, and now we know these positive charges are what? Protons, and protons found by Ernest Rutherford. It took some time, but you got an idea, right? This is how Ernest Rutherford conducted gold foil experiment to get an idea about atom. Okay? So, it is said that comparatively, if atom size is similar to size of a football ground or cricket ground, nucleus is something like chickpea. නිකන් හිතන්න ෆුට්බෝල් ග්‍රවුන්ඩ් එකේ ක්‍රිකට් ග්‍රවුන්ඩ් එක වගේ නම් ඇටම් එක ඒකේ වැටිලා තියෙන නිකන් කඩලැටයක් වගේලු නියුක්ලියස් එක. Very small, extremely small. Right, okay. Someone's mother is there. Turn and see. Right, okay. Got it? Right. Now, with that, we can read and conclude this and highlight even. The structure of an atom. Atoms are tiny invisible particles we cannot observe even under microscope, can't observe. It is made up of subatomic particles. Three main subatomic particles are electrons, protons, neutrons. And remember one thing, when you write electrons, protons, neutrons, last three letters are NES-ONS. Check. NES-ONS. NES, ne? NS. When you write protons, NS. Electrons, NS. Neutrons, NS. Some students write NES. It's wrong, eh? Harida. Protons, electrons, neutrons, the NES ලියනවා කට්ටිය. ලියුවොත් වැරදි ඈ. NS. Got it? Right. So, three main subatomic particles are electrons, protons, neutrons. I wanted to say tons කියන්න බෑනේ, දෙන්නේ trons නේ. Trons, tons, trons. Remember, no E there. Now let's read about electrons. Negatively charged, should know. You can highlight negative. Very light in mass, you can highlight very light. Revolve in shells, energy levels around the nucleus, you can highlight revolve. Consist of energy in them, you can highlight energy. Right. These things you should know about electrons, right? So you have highlighted negative, very light, revolve, energy, right? Then protons, positively charged, you can highlight positive. Found inside the nucleus, highlight nucleus. Mass is relatively high, don't highlight only. Remember that electrons are not heavy, protons, neutrons, normal. Right. Last one, neutrons. Do not have a charge, neutral, highlight neutral. Neutrons, neutral. ලස්සනට නම දාලා තියෙනවා දාපු එක්කෙනානේ නියුට්‍රෝන්ස් වලම නියුට්‍රල්ට නේ නම් හරි සුදු පාට එක්කෙනෙකුට නිකන් සුදු කියලා දැම්මා වගේ නේ සුදු මෙලික කියලා දැම්මා වගේ නේ හරි සමහර සුදු මෙලිකේ ඉන්නවා කළුම කළුයි මෙතන එහෙම නැහැ නියුට්‍රෝන්ස් නියුට්‍රල් නේද චූටි මෙලිකලා ඉන්නවා ස්ටේජ් එකට නැංගුවොත් කඩාගෙන වැටෙනවා චූටි මෙලිකේ නැංගුවොත් එච්චරට චූටි එහෙම නැහැ නියුට්‍රෝන්ස් ආ නියුට්‍රෝන්ස් නියුට්‍රල් protons positive p අකුරෙන්මයි තියෙන්නේ electrons ඒක නම් negative. Right. Found in the nucleus, highlight nucleus. Mass is relatively high, don't highlight. Remember, they are normal, but electrons are very light. Hurry. Therefore, now listen. When you take an atom, its mass, its weight depends on mass of what? Protons and neutrons. Electrons are floating. Electrons do not give any mass weight for this atom because they are going, they are floating. Like you know our earth's weight, say our earth's weight is made by soil, trees, water, rocks. Can we take clouds? We don't take, because they are they are floating like that. Okay, that story is there in the last two lines. Atoms have equal number of protons and electrons. What? It's a new thing, yeah, it's a new thing. Atoms have equal number of electrons and protons. I told you these diagrams are wrong. One point now you can understand. Electrons and protons are equal, but in right hand side diagram, are they equal? No, there are many electrons and few protons. See, that's why I said this diagram is not okay. Hurry, but to understand, first things you needed this diagram, now not anymore. Right, this says atoms have equal number of protons and electrons. Therefore, atoms are neutral in charge. Can you understand that? If there are 10 protons, positive charges 10, electrons also 10, negative charges also 10. So, positive 10, negative 10, atom is electrically neutral. There are charges, but neutral. Why? Charges are equal. Like someone is getting 100,000 rupees salary and that person is having 100,000 rupees loan also. Earning also 100,000, loan also 100,000. Right. Neutral then. We can't say rich also, we can't say poor also. Right. Neutral. Then mass of an atom is equal to mass of protons and neutrons in it. Why? Electrons are not heavy. Nucleus is very small compared to atom and nucleus is positively charged. Why? What's the reason? Protons are there. Okay, we didn't highlight anything there and we don't need also. But if you want, highlight equal number of protons and electrons. First line, equal number of protons and electrons. Right. Now, we are going little by little deep, little by little deep. Right. Page number 2, summary. Subatomic particle, electron, proton, neutron. Charge you have to write. Relative mass in AMU you have to write, other things I have printed. Okay. Let us see electron, last column, found by, who found electron? J. Thomson. Important, only for term test important, found, 4 levels we do not. J. Thomson found electrons, MCQ වලට high. Electron, J. Thomson. Proton, that scientist, Ernest Rutherford. Neutron, James Chadwick. Right? Thomson, Rutherford, Chadwick, names will be enough. But I do not want you to highlight because O-level paper is not going to ask this. Location, energy levels, nucleus, nucleus. Actual mass given in kilograms. Atom so big, very heavy? No. It is 10 to the power minus 31 kilograms, 10 to the power minus 27 kilograms. In kilograms, 0.00000000000, very small, right? So we don't use this usually. You can take your pen and you can cut this column actual mass. We never expect actual mass in papers. Very rarely term test papers have asked. Your Madam Mercer has to have real headache to put this into paper. Got it? Otherwise they don't put. Cut and remove actual mass. As actual mass in kilograms is very small, scientists have found the column before that. What is it? Relative mass in AMU. That you have to remember. Relative mass. Mass is measured relative to something, not relative to kilogram. In relative to kilogram is very small. So we define a new unit to find masses of these. It is AMU. What is AMU? Amukahada? Amukaha. No. What is AMU? AMU is in unit 7. Yeah, unit 7, another boring 7th unit. Another boring long unit. But it's boring like unit 2. AMU is in your unit 7. AMU is atomic mass unit. Atomic mass unit. So for the moment you can write somewhere AMU equals atomic mass unit. පටන් ගත්ත නිදා ගන්නද? කමන්නේ අමාරු ඔලු තියන්නේ. AMU equals atomic mass unit. Atomic mass unit. නැත්තම් බලයි නේද මොකක්ද යකෝ මේ AMU. Right. In atomic mass unit, you have to remember their masses and you need the charge. You try. Can you write their charge? Oh my God. I didn't ask to cut everything. I asked to cut atomic mass column only. Come on. Come on. Hari. I ask you to cut and remove atomic mass. Sorry. Actual mass column. බලන්න හරිද කියලා මම ඔයාලට කපලා අයින් කරන්න කිව්වේ actual mass කියන column එක විතරයි කිලෝග්‍රෑම් තියෙන්නේ බලන්න හරිද හරි සමහරු එක කට් කරලා නැහැ කට් කරන්න ඒක හරි සමහරු වෙන ඒවා කට් කරලා ඒවා අයින් කරන්න kilogram value විතරක් cut and remove. Got it? Right. Can you write charge of this now? You all can write, but I think none of you can do it correctly. Maybe none of you, but you try. ලියන්න charge එක වැරදුනොත් හොඳයි මතක හිටි. Don't you know the charge of electron? You know, then write. Don't you know the charge of proton? You do, write then. Neutron? You do, write then. Hari, ලියුවානේ. Electron, proton, neutron. Electron, proton, neutron. Electron, proton, neutron. Right. First one is electron. Electron is negatively charged, so you have written like this. Proton is positively charged, so you have written like this. ලිව්වේ නැත්නම් වැඩක් නැහැ. හරි? Neutron charge එකක් නැහැනේ. If there is no charge, you can put 0 there. You can write neutral there. Okay? You can write no charge there. But this is not enough. This is not enough. Why not enough? That's why I told you maybe no one can write it correctly. Right. Electron's charge is -1. Put that 1. Proton's charge is +1. Then neutron 0 1. No. Neutron is 0. Or you can write there neutral. හරිද? ඔය දෙකම ලියන්න. ඇහුවොත් write the charge of neutron. You write 0 inside brackets neutral. නැත්නම් neutral inside brackets 0. Right there? Got it? Check it. භාගෙට ලියන් ඉන්නේ සමහරු නෙගටිව් ලියලා මදි -1 කියලා ලියන්න ඕන. පොසිටිව් මදි +1 කියලා ලියමු. මෙයාට 0 නැත්නම් neutral. Right. Then using these charges and these masses. Charge is this, mass is how much? Masses I didn't give, ne? Right. Can you remember electrons are not heavy, very light in mass? Yes. Protons are heavy, neutrons are heavy. So in atomic mass unit, proton is 1 AMU, neutron is 1 AMU, electron is 1 divided by 1836, but we write 1840. So in atomic mass unit, proton is 1, electron is this much, neutron is this much. Right. Proton's mass is 1 atomic mass unit. Neutron's mass is 1 atomic mass unit. Electron's mass is 1 divided by 1840 atomic mass unit. That's why we don't care weight of electron. These two decide weight of the mass of the atom. Hari. These two are the most important columns here. Hari? Right. මේගොල්ලෝ නම් මතක තියෙන්න ඕනේ. Even you can highlight charge, relative mass. You all should remember. Founder won't come. Kilogram value won't come. Location we know. Right. Now I told you electrons are written as E. Similarly, protons can be given this way, neutron can be given this way, electron, proton, neutron. But if we can write them with this, we can represent them much better, in much fair way. Like when we write our name, we put our degrees if we have ne. දානවනේ. ඔය දාලා තියෙන්නේ. මේ නම ලියලා degrees එහෙම දානවා. එතකොට ඒක it's standard. It's a standard. Same way, when we write electrons, protons, neutrons also, we can write in standard form, standard notation by mentioning these also. නේද? දැන් අපි ওই ටියුට් වල එහෙම නම විතරක් දාන්න නැතුව අපේ අධ්‍යාපන සූසුකම් මනම් දානවා. දැන් මම සමහර අයට ඒක හොඳයි. සමහර අය නම් සමහර අය බලනවා මොනවද තියෙන්නේ උග ඉගෙන ගන්න නැද්ද දන්නෙත් නැහැ නේ විභාග ෆේල් දන්නෙත් නැහැ නේ බලනවා. හරි? ඒක දැම්මම තව ටිකක් හොඳයි. ඒ වගේ when we write electrons, protons, neutrons and atoms also, sometimes we mention two values. One is charge, one is mass. Then we can get a complete picture, right? So let's take proton. Proton's charge is +1, no? +1. So like here, you can see positive is not there, 1 is there. When we write neutron, neutron has no charge. So we put 0 here. You can see it here, 0. Electron, -1 in charge, we write charge here, -1. This way we show their charges. And their relative mass, we write up, relative mass. Electron, this much, can't write even here. It is 0 point something, ne? We write 0. That's why electron you get 0 there. Okay, mass of electron is 0.000 something, ne? So we write 0. Like say for science exam, you get 0.001% science වලට. ඔක වැඩක් තියෙනවා අපි 0% කියලාම දානවා වැඩ ඉවරයි නේ. හරිද? Like that it is 0. Proton mass is 1. Neutron mass is 1. For them, we write here 1, 1. This way, when we write the charge and we write the relative mass, we get a standard form. So, write in this box standard notation, a standard form, standard notation, something like that you can write. Exam day, if you have to write electron, proton, neutron or any atom in a standard form, standard notation, you write with charge and mass. Got it? Hari, liwada me box එක ඇතුලේ standard form, standard notation කියලා අපි ලියනවා. Hari. And this message is for those who came little late. We started unit 3 and before interval we do as much as we can do chemistry. After break we will finish unit 2 O level past papers homework. Hari, if we get more time again we come to this one. හොඳයිනේ උදේ පාන්දර homework කරන්න ගත්තේ නැහැ මේ අලුත් පාඩම් පටන් ගත්තා ඊට පස්සේ ඉන්ටර්වල් එකෙන් පස්සේ physics ඉවර කරලා ආයෙත් මේකට යමු right දැන් මේ Saturday this Saturday our target is page 1 සෙන්සර් පන්ති 7 වෙනි පිටුව කරන්න තියෙනවා ඉතින් අපිත් එතෙන්ට යන්න try කරනවා ඒකයි මේ නිවාඩු දවසේ ඕගොල්ලෝම අල්ලගත්තේ right මොන අප්සෙට් ඉතින් මාත් හරි ආසයි ගෙදර ඉඳලා පොඩ්ඩක් ජොලි ඉන්න බෑ ඔයාලගේ රිසල්ට්ස් හොඳ නම් තමයි මට ජොලියක් කියන්නේ නේ. O levels වල හොඳ ඒ ගානක් ආවම ඒක තමයි අපේ ටාගට් එක. Okay. Right. Okay. හරි. Done. Next step now. In next step you can see there's a table and there's a diagram. What is this diagram? This diagram is there's a black color ball here. This black color ball represents nucleus. This has protons and neutrons. Around this you can see there's a circle, there's a line and there's another one and there's another one. What are these? These are energy levels, these are called shells. Energy level closest to the nucleus is called first energy level, it is called K. Outer one, second energy level L. Next one, third energy level M. 1, 2, 3, 4 K, L, M, N energy levels are marked. First energy level closest one, second energy level fourth energy level N. Now you are going to learn how many electrons can be there maximally in these energy levels. Like in the first bench, how many students can sit maximum? I am the nucleus, right? First energy level. In the second one, how many students can be and can maximally be? Then first energy level 0 students, second energy level 3 students, next one 3 students, 4 students, oh no. Like that. How many electrons are there maximally in each energy level? You all have to remember, this is MCQ. It's a direct question. How many electrons are there in the fourth energy level of an atom? 1, 2, 3, 4 answers. Got it? Right. First energy level is a very small one. In this first energy level, remember maximum there are only 2 electrons. Can't be more than 2. Say an atom has 3 electrons. First 2 electrons can be in first shell. Third electron has to go to next one. Harida. Next one. Second level, energy level is a larger one, bigger one. There can be maximum 8 electrons. Harida, hitandako one atom has 6 electrons. 2 in the first energy level. 6 ne, how much is the balance? 4. Where are those 4? Those 4 here. Up to 8 there can be. Say atom has 11 electrons. 2 in the first one, 8 in the next one. Is there any balance? Yes, 1. That one has to go to next one. In the next level, usually maximum 8 are there. But this has a space to keep 18. But usually 8 are there. No 9. This way, fourth shell maximum 32. These values you have to remember. Now one last time. First level 1O maximum 2. Second level 1, 2, 3, 4, 5, 6, 7 maximum 8. Third one 1, 2, 3, 4, 5, 6 maximum 8 usually. And the other electrons go to fourth one. Right? but third energy level has a space to keep up to 18 electrons. Really, there are more than 8. Our syllabus has only one example where there are more than 8, but it is when they are making chemical bonds with other atoms. When atoms are single, always maximum 8. But when they combine with other atoms, they can go beyond 8 up to 18. හරිද? atoms තනියම ඉන්නකොට උපරිම 8යි තියෙන්නේ තුන්වෙනි ෂෙල් එකේ. ඊට වැඩි තියාගන්න නැහැ. හැබැයි වෙන කවුරු එක්ක බොන්ඩ්ස් හදද්දී 18ක් වෙනකන් තියාගන්න පුළුවන්. තියාගන්නවා නෙවෙයි තියාගන්න පුළුවන්. හරි? Therefore maximum 288. But potential is up to 18. So therefore we write here sometimes 288, sometimes 2818 also. ඕමත් අපි ලියනවා. හරිද? එහෙනම් maximum 18 here. Maximum numbers are 18. හරිද? Sometimes we write like this 8. ඒ කියන්නේ as I told you when they are single 8. Okay, now that the story is here. Arrangement of electrons in energy levels. Energy level 1, 2, 3, 4 K, L, M, N. Maximum number of electrons 2, 8, 18, 32. Right, I have to make a call. What do you like? What's the color you prefer for the second part of this tute? Limited colors are there. Then your part 2 was red ne. This one is blue. එතකොට don't give red, don't give blue also නේ. වෙන මොනවා හරි දෙන්න ගියායි නේ. ඔව් නේද? මේකේ part 2 මම print කරන්න දීලා ආවා. මම කිව්වා මට call එකක් දෙන්න කියලා තියෙන colors ගැන. මොකක්ද ඔයගොල්ලෝ කැමති color එක? සුදු පාටද? සමහර white වලටත් කැමති. message එකකුත් එවලා පොඩ්ඩක් ඉන්න. බලමු මොනවද තියෙන colors කියලා. කියන්න එපාද? ඕකේද? මොනවද තියෙනවා කියන්නේ?
අම් පාටයි, තැඹිලි පාටයි, මැජන්ටයි, නිල් පාටයි. පාට හතර තියෙනවා සර්.
ඕක කියන්නේ.
දම් පාටයි, තැඹිලි පාටයි, මැජන්ටයි, නිල් පාටයි. පාට හතර තියෙනවා සර්.
මොකද හොඳ? මොනවද තියෙනවද මේ? දම් පාට. ආය නිල් පාට එපානේ. මැජන්ටා. මැජන්ටා was your part 2. ආය මොකක්ද තියෙනවද? තැඹිලි. තැඹිලි හොඳයිද? Purple ද orange ද? Right, let's vote. Purple. Purple ලයි පොඩ්ඩක් අත උසන්න. ලැජ්ජ වෙන්න එපා. එහෙනම් තැඹිලි ගහනවා ඈ. Purple ඕන නම් අත උසන්න පොඩ්ඩක්. මම just ගන්න යන්නේ කාගේද hands වැඩි කියලා. Purple. Right, hands down. Orange. Hari, more votes for orange නේ. Let's give orange. No, sorry, purple. Hari, purple දෙමු. දම් පාට ටියුට් එකක් අපි ළඟදී කරානේ. මොකක්ද ඒ? grade 11 වෙන්නදී. හරි. purple දෙන්නේ. හරි. next ටියුට් is purple. මේ රජිතය purple දාමු එහෙනම් ඈ දම් පාට. දම් පාට දම්. හරි. Now, as I told you, I went to printing shop morning before coming to class. Right. So part 2 is going to be purple. Ne? Hari, your request. Very hariyak kiwe purple kila. Right. So even though space is for 18. Practically, naturally, usually there are only 8 in the third shell. It's a special thing, and with evidences I am going to prove that, and you have to remember 18ක් තියාගන්න පුළුවන් වුණාට සාමාන්‍යයෙන් ඉන්නේ 8යි උඩරිම. උදාහරණත් එක්කම බලමු ඈ. Right. In atoms when they have not reacted, Maximum 8 electrons exist in the third shell. Example, potassium atom has 19 electrons. They are found as in the first shell 2, in the second shell 8, in the third shell also 8, and last one goes to last shell. Can't third shell keep that one? Can, but usually not. That's the nature. So we are studying nature. Hari, existence. Calcium atom has 20 electrons. They are found as 2 in the first one, 8 in the second one, 8 in the third one, and last 2 has to go to fourth one. Can't third one keep 10? Can, but usually not. හරිද? අපි ඉගෙන ගන්නේ nature එක, ස්වභාවය තියෙන දේ. කොහොමයි තියෙන්නේ. Right. Now this proves that third cell usually keeping 8, but maximum 18. Okay, this table is important. Put one red star there. It's a direct MCQ question. Which of the following is giving you number of electrons present in the second level, third level නැත්නම් K, L, M, N respectively. All four can come. එහෙමත් වෙනවා K, L, M, N respectively. Right. 2, 8, 18, 32. Right. Then special one. But when atoms react and form chemical bonds, third shell can keep up to 18 and fourth shell can keep up to 32 electrons. You know that. One example. Phosphorus has 5 electrons in the last shell. Last shell කියන්නේ අතරම third shell. Third shell එකේ 5 ලු තියෙන්නේ. Okay, shall we cut this last and write third? Third කියලා ලියමු. Phosphorus has 5 electrons in its third shell. කියලා ලියමු third shell. Last කිව්වම you don't know how many shells are නේ. Third shell. Right. When it forms PCl5, this particular compound PCl5, phosphorus pentachloride, it keeps 10 electrons in third shell. Last නෙවෙයි third shell කරමු. Third shell. Hari. And usually third shell is keeping 8. Phosphorus has only 5. But when phosphorus is making PCl5, it is keeping there 10. It's not an issue. Can keep even up to 18. 10 මොකක්ද ඕනනම් 18ක් තියාගත්ත හැයි. Right. Hari. So should we remember this special example? No. This is going to be in unit 10. We are going to draw phosphorus pentachloride molecule. අපි අඳිනවා. Dot cross diagrams එක අඳිනවා. Right. දැනට ඕනේ. Right. Next special thing. Shells have specific energy because electrons have energy in them. Higher energy levels further away from the nucleus have more energy than energy levels closer to the nucleus. So electrons, when you take an electron in third shell, it has more energy than one electron in first shell or second shell. හරිද? ඈතට යන්න electrons වැඩි අයලු ඉන්නේ. හරි. යා මෙහෙම දාන්නකො. Someone's home has one floor. Another one has 2. Another one 3. Another one 4. Ne? If you marry a person who has 4 shells in the house, you get more money. අය වගේ නේ. හරි. මම නිකන් කිව්වේ හරි. සමහර අයගේ ගෙදර එක තට්ටුවයි, සමහර අයගේ තට්ටු දෙකයි, සමහර අයගේ තට්ටු 3යි 4යි. හිතන්නකො තට්ටු 4 ගෙදර ඉන්න එක්කෙනෙක්ව මැරි කරනවා. එයාලම සල්ලි වැඩි වගේ නේ. ඒක තමයි atom එක. When you take an electron in the first shell, low energy. Second shell, more. Third shell, more. Fourth shell, even more energy. Right? හරි. And don't think about that example නේ. හරි හරි නම් මම තට්ටු. එහෙම නෙවෙයි Just example to remember. Okay. Models to describe the structure of atom, and you know the latest model which is called quantum mechanics. We finished now. Now we are going to talk about old models, weak models with wrong things, mistakes, right? There are many such old models. Only 2 are there in our syllabus, and these early models are not going to come for O levels. These models come only for what then? TT, table tennis. No, term test. හරිද? මේවා આવුත් වෙන්නේ term test එකට විතරයි. So you write here models to describe the structure of atom. In front of that topic you write only for term test. So you study for your first term test, thereafter don't. හරිද? O level kit වෙලා පාඩම් කරද්දි මේවා පාඩම් කරන්න එපා. ඒ වෙලාව අපරාධි ගොඩක් වෙලාවට එන්නේ නැහැ. පළවෙනි ටර්ම් ටෙස්ට් එකට විතරක් පාඩම් කරගන්න. හරි? right. Why is it so? Because these are wrong, no? These are wrong models. So we have correct model now. This correct model also one day can be wrong, ne? One day people will learn under early models what we consider now as correct also. Science is changing, that's why. Atom is not changing, our knowledge is what we know is changing, we find new things, right. So, earlier models of atom, there are two only in syllabus, planetary model, Niels Bohr model. I can remember there was one more, there was one thing called, one model called plum pudding model, which talks about plums in an apple pudding when describing atom. It's really nice, ne? But we don't need it because it's very simple, it's very wrong, that's why. These two are little okay, right. First one, planetary model, look at this one. Now when you look at the diagram, you can understand nucleus is like our sun, moving electrons are like our planets. Okay. The biggest issue mistake here is in our solar system, in one orbit, how many atoms? Atoms, no way. How many planets are there in one orbit? Only one. Our planet is in our orbit, nothing more, nothing else. But in an atom, when we take a particular orbit, there can be 2 electrons, 8 electrons, 18 electrons even. Got it? Therefore, we can't say atom is like our solar system, electrons are like our planets. කියන්න අමාරුයි. තේරුණානේ? ඒක තමයි වැරද්ද. Right. But let's read it. Introduced by Ernest Rutherford. For your term test, maybe you need this planetary model by Ernest Rutherford, but don't highlight even. After that, you are not going to need. හරිද? Say හිතන්නකෝ someone taking 5 minutes try to remember all these. It's very bad for O-level exam. Got it? හිතන්න O-level කිට්ටු වෙලා විනාඩි 5ක් ගන්නවා මේ ටික පාඩම් කරගන්න. එහෙන අපරාධයක් නේ. එන්නේ නැහනේ. එයා highlight කරන්න එපා. right, term test එකට දැනගන්න. right, එහෙනම් introduced by Ernest Rutherford states that positive charges are concentrated in the nucleus. Hari, correct. Electrons move around the nucleus, correct. Like planets revolve around the sun in solar system. There is something not okay there. Electrons are attracted by the positive charges in the nucleus. You can understand that. Negative things are attracted by positive and positive by negative. එහෙම එකක් තියෙනවා. නේද? You know our sun attracts all the planets and planets attract sun. There are mutual attractions in between. But they do not fall on it as they are moving very fast. Our planets are pulled by sun, no, but we are not going towards sun. There are attractions between sun and planets, but none of the planets are going to meet the sun. Why? Because planets are moving very fast. So what? While moving can go. While moving can go. ඔයාලා අහලා තියෙනවනේ අර මාරකලින්ද කියලා එකක්. ඩෙත් වෙල්ද මොකක්ද ගන්නෙ? මෝටර් සයිකල් යනවා කියන්නේ. ෆුට් සයිකල්ස් also, vehicles also නේ. Why don't they fall? Why don't they fall? Yummy, mummy. It's like this. You don't have heart attack, ne? Heart attack nae? Heart attack තියෙනවනේ? Attack nae? The heart attack එනවා. හරි. I am going to write this one, ne? හරි මෙතනින් ගමු. So this one. බයවෙන්න එපා, heart attack නැහැ කිව්වේ. If it goes out from my hand, will it fall here down? No, it will go away from my hand. නේද? මෙයාව හයියෙන් කරකවලා මම යන්න දුන්නොත් එහෙම එයා මෙතනින් ඈතට නේද යන්නේ. Why? While moving, when something is moving, it is developing a force to go away from its center of rotation. Right? මෙයා හයියෙන් කරගෙද්දී එයාට force එකක් එනවා finger එකෙන් ඈතට විසි වෙන්න. නේද? Anything moving like that is getting this force to go away from the center. In that well also it is same. Vehicle is getting force to go away from the center and it can't go because it is traveling on the wall. Okay? Got it? Like planets, electrons, while moving, they are getting a force to go away from the center. And this going away force is equal to the attraction of the sun, attraction of the nucleus. Got it? So, when we take a planet, attraction towards the sun is equal to this force, as these are equal, not going towards, not going away. Electrons also same. Harida? Nothing happened. Harida? Anything moving in a circular path is having a force to go away from the center. In atoms, in our solar system, in all those examples, this outward force is equal to inward force, therefore it is stable. Got it? But the simple story is given in simple words here. They don't fall on it as they are moving very fast. Harida? තරහයි මගෙත් එක්ක මේක කරගවල නේ නෑ මම මේ සමහර ඉතින් හරි ආදරේ මේවට අදනවලක් කැමති නෑ කවුරුත් ඒක හරි වතුර ටිකක් එහෙම බොන්න සෙට් වෙන්න next part එකට got it right now Niels Bohr model remember we don't highlight because most probably 0 questions come from this even for term test එකකට එකක්වත් එන්න දෙන්න පුළුවන් right introduced by Niels Bohr further elaborated planetary model. That means Niels Bohr didn't reject planetary model. Niels Bohr developed, improved this planetary model. So, planetary models basics are inside Niels Bohr model. Harine? Okay, right. Say someone starts a project, someone else, the next officer appointed finishes it like that. Maybe improves it. Right, introduced by Niels Bohr, further elaborated planetary model states that electrons move in definite circular paths or shells around positively charged nucleus. Size of shells and energy in them is fixed. So, don't learn by heart, no need to remember even, just listen. Hari, he said electrons have definite circular paths. That's all given in textbook, but I added one thing, that's why its font is different, font size also is different, because Niels Bohr expressed that also. What is it? When electrons jump from one shell to another, what? Can electrons jump from first level to second level to third level? Can. It's a new thing, that's why I added, right? When electrons can jump from one shell to another, that means electrons can jump. They emit energy as radiation or they absorb energy. Now, this is the story. I told you that electrons have energy. Which electrons have more energy? First level or second level? Which electrons have more energy? Second shell. Like someone's home is like one floor, say ground floor. This person gets lot of money, say lottery or something. What happens? He removes the roof. Without roof in no, makes another one. Now first floor ground floor and first floor, like that. Because of getting money can go to upper level, more money can go to upper level. Got it? Like that, if electrons get some energy, electrons can go to next level, next level, next level. But in these levels, electrons are not stable. Electrons again fall down back to the initial level. Then the energy absorbed, they emit radiation. මේ පල්ලෙහායින් ඉලෙක්ට්‍රෝන්ස් වලට ශක්තිය දුන්නොත් එයාලට පුළුවන් ශක්තිය අරන් උඩේවට පනින්න. හැබැයි එතන හැමදාම ඉන්න බෑ, එක්සයිට් වෙලා ඉන්න බෑ එතන. It's called excitement. ආයෙත් වැටෙනවා. වැටද්දී absorb කරපු energy release කරනවා. I can give you two simple examples for this from the environment. One is photosynthesis. You all know light energy is absorbed by chlorophyll. So, chlorophyll is made up of atoms. Atoms have electrons, light energy they absorb, and chlorophyll atoms electrons go to upper energy levels, absorbing light energy. Then they fall down, releasing that energy again, but not as light energy, another form of energy. That energy is used to run photosynthesis reactions. That's how photosynthesis is absorbing light energy. Syllabus again. Another one from CFL bulbs. Now we don't have CFL, we have better LED. but we had CFL, still we can find. These CFL bulbs have compact fluorescent lamps. CFL bulbs have mercury vapor inside them. Mercury vapor, mercury atoms absorb when we give electrical energy. Taking this energy, mercury electrons go up to upper energy levels, and then they fall down again. While falling down, they emit energy absorbed as ultraviolet rays, and these ultraviolet rays strike the white color coat of the bulb called phosphor coat, giving a white color glow. That's white light we use. Two examples for this one. See, nice interesting things, but not in the textbook. So we don't highlight, we don't learn by heart, just listen. Electrons can jump to upper levels by taking energy, can fall down to original levels by releasing energy, emitting energy. Right. So we don't cut and remove, but we don't highlight also. Right. Now we have come to the very important part, the real part. It took about 1.5 hours to do the basics. Right. I can remember our Tuesday class, I started from here. Tuesday Katugastara class, I started from page number 3. Page number 3 වලින් මට මතක හැටියට පටන් ගත්තේ. හොඳයි නේ. දැන් අපි ඊට parallel වෙන්න යන්නේ අද. We try. If you want to drink some water, you can drink. If you want to eat something, not rice and curry, you can eat that. Get some energy and come to next one. 1 minute break. What 1 minute? විනාඩියක break එකක්. ටක් ගාලා නිදා ගන්න එපා විනාඩියෙන්. Is that yours? කිරිල්ලිය දවල්ට නිදා ගන්න නැහැ. කිරිල්ලිය දවල්ට නිදා ගන්න නැහැ නේ කිව්වා. What happened? Karate පාරක් වැදුනද? ගණන් ගන්න එපා. තව තියෙනවානේ 15 seconds. Right. Our real chemistry unit 3 starting now. Right. I am going to describe something and I am going to come down then. මම බලන්නේ. මං චොට්ටක් describe කරලා පල්ලෙහාට එන්න. ඔන්න සිරිපාද ගන්න නැග්ගා. Right. I told you that subatomic particles are described using a standard method this way. Same way I told you we write elements also, atoms also. Hari, atoms also. Then we need atomic number, mass number. Right. Let's take one element, one example. Maybe not there, maybe not there. Okay, නැති එක්කෙනෙක් ගන්නම් මම. ඉන්නවයි මතකවත් නැහැ. Right. අපි 아무තු එක්කෙනෙක් ගමු සාමාන්‍යයෙන් ගන්න නැති එක්කෙනෙක්. එහෙනම් බෑ නේද? I have to use common examples නේ. අයියෝ ආයි බහින්න වෙනවා. Come on. Just show me tute like this. මෙහෙම කරලා පෙන්නන්න tute එක. Right, we get carbon, we get nitrogen, examples of oxygen, sodium, chlorine, sulfur ඉන්නවනේ. sodium ඉන්නවා. sodium ගන්න ගියේ. කවුද ගන්නේ අපි? කමන්න ඉන්නේ කෙනෙක් ගමු. ඒක බෑනේ. Right, let's use fluorine common නැහැ. carbon හිටියානේ. nitrogen also was there නේ. nitrogen හිටියා. magnesium mg නෑ නේද? mg නෑ. Right. Let's take magnesium atom. When we write magnesium, we write capital M and simple G mg. But a standard method, standard notation When we use, we write two more numbers here. Remember, according to national syllabus, local syllabus, we write all these numbers on the left hand side. One left hand side down, one left hand side up. But London syllabus students, EdXL, CIS, Gateway and others, they write these numbers on right hand side, but we write on left hand side. One number is written down. For magnesium it is 12. One is left hand side up. For magnesium it is 24. That means is this double of that? Mostly double. Sometimes double plus 1 or double minus 1. Mostly double. Hari? Samahara wage double to plus 1 minus 1 wage, you know. And these numbers are not full numbers actually. Though we write 12 here, it can be 11.9 something or 12 point something. This can be 24 something, 24 point something or 23.9 something, but we write these full numbers. Listen carefully. This number is giving you how many protons are there. This number, left hand side number, is giving you, that's the duster, dirty duster, right. This left hand side number is giving you, remember, how many protons are there in the atom. Simple V mama liwa. How many protons are there is given by this number, right. And name of it is atomic number. Atomic number. Can't we call it proton number? No, the standard name is atomic number. Atomic number is giving us protons. Very simple. But you know, in any atom, protons in number is equal to something. What is it? Electrons, no? Protons and electrons are equal, making the atom neutral. So this number is atomic number, it is protons, but electrons also you can find from that. But when you have to write what is given by it, what are you going to write? Protons. Don't write electrons. Harida electrons at hoyaganna puluwan. Habai meke kawuda inne hawuth liyanne protons kiyala. Hari protons. Right. Then this upper one is giving you summation of two things. It is protons and neutrons. If you add together, you get this. P plus N. Protons and neutrons, when you add together, you get this. And its name is MASS number. Mass number or mass number. And you can remember it this way also. Mass of atom depends on this one and this one, because mass of electron is nothing. Isn't it? Mass of atom comes when we add protons, neutrons together. So see, when we add protons and neutrons together, we get mass number, mass of atom. Are you there? Right. So this is called mass number, it is P plus N. This is called atomic number, it is P. So if you need protons, look at this, get this number. If you need electrons, look at this, get this number. If you need neutrons, tell me how many neutrons are here. How many neutrons are there? When you add protons and neutrons, you get 24. Only protons 12. How many neutrons are there then? 24 minus 12. Ne? 24 minus 12. That means neutrons come when you subtract atomic number from mass number. Got it? Therunada? Neutrons subtract current atomic number, mass number again. Right. So I write here mass number mn subtract minus atomic number, and this atomic number is called Z, and mass number is called A. Remember, A is not atomic number, A is mass number, right. In other words, you get A minus Z neutrons. Simple neither. How many neutrons are there then? 12. මෙයාට අපි ගත්තොත් 24 minus 12 neutrons 12. This is very important basic fact. I can show you many times this question, this theory part in past papers, but unfortunately past papers are still inside printing shop. They must be printing it now. Past papers ටික දැන් පණ දාගෙන print කරනවා ඇති. මම next week වගේ දෙන්නම් ඈ. හරි. ඔන්න අපේ next story එක. Very important and very simple. Right. Atomic number and mass number. Ready? Atomic number. Shall we write on the left hand side of the topic atomic number? What is atomic number? Simple P. Right here simple P. Simple P. One පැත්තෙන් අපි ලියමු ලොකුවට simple P atomic number. Then mass number P plus N. Simple P දාමු capital P දාන්න එපා අපි simple මයි ගන්නෙ. Right, P plus N mass number. Near atomic number simple P, near mass number P plus N. එහෙම තමයි. එහෙම තමයි. Hi, then blank එක. Atomic number. Atomic number. Yeah, atomic number. Blank present in the nucleus of an atom. What is it? Protons. So write there number of protons. Number of protons. Number of protons. Now we are writing answer for the blank. Then some of you have written something there already. අර මම P අකුර දාන්න කිව්වේ ඒක blank එකේ ලියපුවා ඉන්නවා. ඒක ලියාගෙන වම් පැත්තෙන් before topic. Right. Number of protons present in the nucleus of an atom. Inside brackets. In neutral atoms, it is equal to number of electrons. Yes. Atomic number is unique. Varies from element to element. Magnesium 12, but carbon is not 12. Magnesium is 12, oxygen is not 12. 12 is whose number? Magnesium's number. Its identity is unique. Hari, එයාටම ඒ number එක. Anywhere in this world universe, if atomic number is 12, what is that element? Magnesium. Right. Then mass number. Blank present in the nucleus of an atom. Yeah, what is it? Don't write. It is a summation of protons and neutrons. But we don't have to write summation. We can write sum. Not S-O-M-E sum. Which sum? S-U-M sum. Okay, right? The sum of the. The sum of the. හැබැයි S-U-M the S-U-M of the. The sum of the protons and the neutrons. The sum of the protons and neutrons. The summation of the protons and neutrons. Hari. Okay. Okay. Look at this diagram printed. X is not real. It is a symbol of the element like magnesium. Left hand side down one is said atomic number gives you protons. Left hand side upper one A, mass number P plus N. Hari. Now, example carbon, example nitrogen and exercise there. Can you complete carbon? Symbol of carbon capital C, proton 6, neutron 6. Can you write in a standard form inside that box given? Look at sulfur. Sulfur දීලා තියෙන්නේ. අන්න ඒ විදිහට carbon ලියන්න පුළුවන් නම්. වම් පැත්තේ පල්ලෙහා අපි ලියනවා protons ගාන. වම් පැත්තේ උඩින් ලියනවා protons neutrons එකතු කරාම එන ගාන. හරි. සිංහලනුත් කිව්වා දැන් බලමු පුළුවන්ද කියලා. මං චොට්ටක් බය වුණා. ඔයගොල්ලෝ බලයි කියලා මේක. මෙතන තියෙනවා. hits here. හරි. බැලුවා වගේ දැක්කේ නෑ මම බැලුවා ටට්ටක් ගාලා කට්ටිය බලනවාද බැලුවේ නෑ වගේ. හරි. Okay. How to write it? Carbon left hand side down 6, left hand side up 12. Let me write it correctly. Right, this is how we write carbon. Shall I write here? Carbon 6 protons here, protons plus neutrons 12, 6 and 6 12. It is here. That's the answer. Symbol of nitrogen given. Draw it. Standard method again, Leon. Standard method. And you can write somewhere here, standard method. The standard form. Standard form, standard notation. Nitrogen. What is the standard form notation of nitrogen? Nitrogen is N1714 here. N714. So some people read this 14N7, some other people 7N14, some other people N714. You don't have oral examinations, your written examinations, write it that way. හරි. ඉතින් ඇහුවා මේක අපි කොහොමද කියවන්නේ? 14N7ද 7N14ද N4ද 714ද 14 ඒක එච්චර හිතන්න එපා. දැන් මම නම් කියන්නේ carbon 612 nitrogen 714 සමහරව අනිත් පැත්තට ඒක අවුලක් නැහැ. අපිට තියෙන ලියන්න. Right. Now exercise. Write symbols of following elements with mass number and atomic number. I have given a small boxes. Complete 1, 2, 3. Fourth one also complete. Hurry, try කරන්න. Fast. 1 minute for all. You're ready? Complete. You got a good news while working. Listen. Now this our online team, advanced online class, is giving you opportunity to join one class per month free of charge online for physical class students. That kind of message. ඔයාලට ෆිසිකල් අයට මාසෙට දවසක් මේ IMS කාඩ් එකෙන් බාකෝඩ් එක ඒගොල්ලන්ට ෆොටෝ එකක් ගහලා යවලා මේ ජොයින් වෙන්න පුළුවන්. හැබැයි දවසකට කලින් ඒක කරගන්න කියලා තියෙනවානේ. Yani if you know that like you are going to miss a particular class, not through me directly, there's a number of admin that kind of message එක. You have to take photo of IMS card and send them and you can get link. දිමුතු එහෙම නේද? දවසක් කලින් ඕනනේ. කාටද යවන්න කියලා තියෙන්නේ? චේතනටද? ඔව් ඒකේ නම්බර්ස් වගේක් තියෙනවා මම නෙවෙයි. ඕම් මට කතා කරන්න එපා උදේ සර් අද හවස එන්න වෙන්නේ නැහැ. ලින්ක් එක දෙන්න මම නෙවෙයි කරන්නේ. ඒගොල්ලෝ ගොඩක් බිසි දැන් මේ වෙලාවේ මේ මෙයා මෙතන ඉන්නවා තව කැමරාස් තියෙන කීප දෙනෙක් A level classes එහෙම කවර් කරනවා. ඇඩ්මින් ගැන වෙනම ඉන්නවා. ඔක්කොම බිසි. ටක් ගාලා කියලා ගන්න බෑ. මම ඕකේ මිලෝදයක් දන්නේ නැහැ. මගේ නෙවෙයි සයිට් එක. හරි? ඒගොල්ලෝ හරහා කරගන්න පුළුවන් මේ මේ chance එක තියෙනවා. දැන් මම නම් ඕක දෙනවට ඇත්තටම කැමති නෑ අයියේ. ඒතර කට්ටිය සතියට සැරයක් මාසෙක දවසක් එන්නේ නැහැ ක්ලාස් එකේ. ගෙදර ඉන්නවා. අනිවාර්යෙන් මාසෙට දවසක් සමහරු එන්නේ නැහැ. ඒකවල ගෙදර ඉන්නවා. ආයෙ පුළුවන් නේ. ඉතින් අපිට ක්ලාස් එක පාළුයි ඉතින්. නේ? කමක් නැහැ. ඉතින් දවසයිනේ chance එක තියෙනවා මේ කැමති අයට. But I know you like physical classes. Yeah. It's actually I don't know physical is better, online is better, but physical is like you can feel this environment, competition and all. හරි ඔන්ලයින් කට්ටිය තරහ වෙන්න එපා ඈ. කවන්න නැහැ ඒක ඔන්ලයින් හරි කවන්නේ. හරිද? ඉතින් එක දිමුතු එක දවසක් තියලා කලින් යවන්න ඕනනේ. එන්න හෙට ක්ලාස් එක නම් අද උදේවත් ඕනනේ. අද රැහැම යවලා බෑ. ඒගොල්ලොත් humans they have many other work, so as a help they are giving hybrid class concept. දැක්කද message එක? ඔව් මම එවලා තිබ්බා. group එක බලන්න. group එකට if you have not joined the group please send me your school name, grade, my number is here and join our WhatsApp group. Right. For online students, we have not created any WhatsApp group. Yeah, online students also can do that. You can send your name, school and Thursday online class. Or online class grade 10, send me message. We can add you. Right? Hari. Shall we? Right. Exercise. Symbol of oxygen is O. Symbol of oxygen is O. So we write symbol. I write here. We write symbol O. Then 8 protons. Protons here. 8 neutrons. Neutrons have no place to write, but neutrons are inside this. Symbol of sodium is Na. So we write the symbol Na. It has 12 neutrons. Neutrons nowhere. Protons 11. So here what you write is 11, not 12. 12 we write nowhere. Up 11 and 12, 23. 23. Write the last. Chlorine. Chlorine Cl. 17 protons here. 18 neutrons, 17 and 18 together 35, 35 here up. Right. Then next one, sulfur 16, 32. Various questions are there about it. Atomic number, answer is 16. Mass number, answer is 32. Number of protons, answer is 16. Number of neutrons, answer is 16. It is 32 minus 16. 16. Electrons, 16. Right. Now our next step is a bigger step. Bigger step. Unfortunately, O-level papers are in part 2. Otherwise, can do some O-level past paper questions here, but unable to do. From next week, I am starting past papers. Right, from next week. Next one is isotopes. To understand isotopes, feel isotopes. I have given you H11 atom, H12 atom, and H13 atom. H means hydrogen. We thought that hydrogen is hydrogen. But now you can understand hydrogen is maybe H11, maybe H12, maybe H13. Hydrogen should be hydrogen, no. But there are 3 types of hydrogen. These 3 types of hydrogen are called isotopes of hydrogen. This one is called protium, this one is called deuterium, this one is called tritium. Penawada? Nam wagයක් තියෙනවා. දැන් මාර වැඩන්නේ. කවුද එතකොට hydrogen? 3 දෙනෙක් ඉන්නවා. මාර වැඩන්නේ. What to do? Some elements have different types of atoms. These are called isotopes. This one is protium, this one is deuterium, this one is tritium. කරන්න දෙයක් නැහැ. We have to learn about them to handle them. Right. In these isotopes of hydrogen, one thing is common. What is it? And one thing is different. What is common in these isotopes? We learn now, we record here now. දැන් ඔලුවට ගන්න. හරි. What is common in these? Don't say H. H තමයි ඉතින් මොකද්ද? 1 1 1. 1 1 1. And you know this 1 is atomic number, and atomic number is unique for an element. If it is 1, everywhere in this universe it is hydrogen. Got it? Right. Therefore, if they are hydrogen, they have to be 1 1 1. Protons equal. If protons are equal, electrons also are equal. What would be different then? Maybe neutrons. Are neutrons different? Let's find out. I have given a space to find protons. How many protons? 1. I have given you space to write protons. How many protons? 1. How many protons? 1. Hurry. Let's find neutrons and find whether neutrons are equal or not. I want you to fill how many neutrons are there in each. Liand. Neutrons කීයක් තියෙනවද? එක එක්කෙනාගේ. ලියවා. Neutrons. So those who wrote neutrons of hydrogen, only hydrogen, we have hydrogen only, if you get a statement like this, for levels, certain atoms, there are certain atoms without neutrons? Are there atoms without neutrons? You know that atoms have electrons, protons and neutrons. Are there atoms without neutrons? Your answer is by looking at protium, yes. Protium, neutrons 1 minus 1, 0. ඒ කියන්නේ මේ ලෝකේ atoms තියෙනවා neutrons එකක්වත් නැති. Remember, what is it? Protium. Hari? Right. Second one, neutrons 2 minus 1, 1. Third one, 3 minus 1, 2. This way, in these atoms, neutrons are different. As a result, mass numbers are different. What do we call them? Isotopes. Allotropes have isotopes. Now we can get a definition for isotopes. Listen carefully. Isotopes are the atoms with different mass numbers of the same element. That's the definition. One last time. Isotopes are atoms with different mass numbers of the same element. All together? Isotopes. Isotopes are, right, atoms with different mass numbers. Atoms with different mass numbers. Atoms with different mass numbers of the same element. Of the same element. Atoms with different mass numbers of the same element. Right? Highlight this definition. You have to learn by heart. It's a possible direct question. What are isotopes? Harida. Highlight කරන්න තරුවක් දාන්න කෙලින්ම අහන්න පුළුවන් එකක්. What are isotopes? Be careful, there is something called allotropes in future. Very soon in part 2, these are not allotropes, these are isotopes. Okay. Right. Then I want you to highlight 3 names of them: protium, deuterium, tritium. ඔය නම් තුන highlight කරගන්න මතක තියාගන්න. මෙයා protium, අරයා deuterium, අරයා tritium. Highlight those 3 names: protium, deuterium, tritium. දැනගන්න ඕනේ. Now you are thinking that you know about isotopes, ne? දන්නවා චුට්ටයි තාම දන්නේ. Can you complete chlorine and carbon by writing protons, neutrons alone? You know, interval is around 10:45 වල වන්නේ. කලින්ම ගෙවේ නැත්නම් කට්ටිය බලයි. Watch me. We are going to take only one interval because we have many things to do. It's going to die. Look at the face. අවුලක් නැහැ නේ. I am very happy because I can take your class to other class level. I was really upset because this class was the last class, and unluckily we got one poor day, but last week you could cover it, and luckily this is May 1st and we can do extra classes. මම හෙන අප්සෙට් එක හිටියේ අපේ online class එකයි මේකයි තමයි පරක්කු වෙලා හිටියේ. අපි ගිය සතියේ නේද පැය 4ක්ද කොහෙද දැම්මනේ ගිය සතියේද? පැය 4ක් දාලා මිස් වෙච්ච එකක් කවර් කරා අදත් ඔයා කරන්න බෑ. දැන් හරි දැන් parallel ආයි කරේ. And don't worry, unit 4 and unit 5, both units we cover everything in 3 days. Past papers කරන්න තියෙනවනේ නැත්නම් දවස් දෙකයි. දවස් 3න් unit 4ක් ඉවරයි 5ක් ඉවරයි. අඩිය අවුලක් නැහැ. And unit 9, unit 11, unit 12, all 3 units one day. එහෙම ඒවාක් තියෙනවා එහෙම ඒවාක් තියෙනවා. Right. Chlorine, I am answering now. protons 17, neutrons 18, 35 minus 17, 18. Next one, protons 17, neutrons 20, 37 minus 17. Carbon then, protons 6, neutrons also 6. Second carbon, this is called radioactive carbon. Do you know that? Radioactive carbon. You know, from dead body's bones, scientists can estimate the age of the body. Maybe 1000 years, 2000 years, 5000 years, 10,000 years කියලා කියනවනේ. Dead bodies, their bones emit carbon 614 at a particular rate. With the age, this rate is decreasing. So using this carbon test, radioactive carbon test, we can detect age of skeletons. එහෙමයි කියන්නේ නේද? Found an skeleton and it was like 10,000 years old කියලා කියනවානේ. බෝඩ් එකක් ගහලා තියෙනවා බර්ත්ඩේ මේ දවස් කියලා. එහෙම එකක් නැහැ නේ, බර්ත්ඩේ මුකුත් නැහැ. එහෙනම් ඕවෙන් තමයි හොයන්නේ. right, carbon 614. Protons 6, neutrons 8. Right. Now we are answering simple 3 questions and very advanced question. Right. 3 simple questions. What are similar in isotopes? Find. Need 2 answers. What are similar? Protons similar, atomic number similar. Right. Protons comma atomic number. Right. Protons comma atomic numbers. Right. Second one. What are different in isotopes? Yes? Neutrons are different, mass numbers are different. Right, both. Neutrons comma mass numbers. So mass numbers comma neutrons. What is the cause of isotopes? What is the reason of isotopes? What's the reason? Because of what isotopes come to this world? Protons an issue? No, protons are equal. Electrons issue? No, electrons equal. Neutrons is the reason? Yes. Even though element is same, neutrons can be different. That's why mass numbers are different. So we can write presence of different numbers of neutrons. Presence of PRESENCE, presence of different numbers of neutrons. Presence of different numbers of neutrons. Presence of different numbers of neutrons. Right. Exercise 1 and 2. I think you all can get 2 correct answers, but maybe no one can get marks at O-level exam for writing those 2 correct answers, because the third correct answer is the very correct answer. ඔයාලා හැමෝටම හරි උත්තර දෙක ගානේ ලියන්න පුළුවන්. එකක් හරි දෙකක් හරි. හැබැයි O-levels වලට marks දෙන තුන්වෙනි උත්තරේ නම් ඔලුවට එන එකක් නැහැ. You have to learn that. හරි. I want you to try, but exercise 1, exercise 2. Try your best. Try to get marks. Try exercise 1, exercise 2. Write the difference between the 3 isotopes of hydrogen. You can see everything here, but still I am telling you, maybe you can't get marks. Why? Okay, what's your answer? I think time is enough for hydrogen. Ne? Difference in isotopes of hydrogen. One difference is, don't write, mass numbers are different. Correct? No marks. Another one correct answer is, neutrons are different. Very correct. No marks. Then you are going to get marks if you write only up to this level. Only up to this level. What is it? H11 has 0 neutrons, H12 has 1 neutron, H13 has 2 neutrons. You have to give these numbers. Just telling that neutrons are different, not enough. Just saying that mass numbers different, not enough. You have to give neutrons how much. Got it? තේරුණාද? එහෙම ලියන්න ඕන එක්සෑම් එකේ. අරයා වෙනස් මෙයා වෙනස් කියලා හරියන්නේ නැහැ. එයා මෙච්චරයි මෙයාගේ මෙච්චරයි අරයාගේ මෙච්චරයි කියලාම ලියන්න ඕන. Then only you get marks for sure. Got it? All right. Write the answer. H11 has 0 neutrons. Like H11 has no neutrons. H11 has no neutrons. Comma. H12 has 1 neutron, comma. H13 has 2 neutrons. Okay, right. That way answer second question. So sometimes a term test day, O-level day, you write your simple answer, you lose marks. And when you turn and see the tute, you can see, this is the answer. Full fit එකේ ඔය වැරදි උත්තරේ ලියනවා ඔයගොල්ලෝ ටර්ම් ටෙස්ට් එකකට. ඔයගොල්ලෝට ලියනවා. full fit හරි කියලා. වැරද්දක් දාලා. ටියුට් එක ලබාදී මේකනේ ආන්සර් එක. මෙහෙම ලියන්න ඕනේ. Right. So what's the answer for next one? Write the difference between two isotopes of carbon. So your answer should be C612 has 6 neutrons. C612 has 6 neutrons, but C614 has 8 neutrons. Only and only. Alright? Now I want you to put one red star and write something about your wrong answer. I don't say wrong answer, your weak answer. Hurry. Put one red star and write. No marks would be given. No marks would be given. No marks would be given. The marks would not be given. No marks would be given for writing that neutrons are different, comma, mass numbers are different. Neutrons are different, comma, mass numbers are different. හරිද? සිංහලෙන් කිව්වොත් මොකක්ද ඔය කියලා තියෙන්නේ? ලකුණු හම්බ වෙන්නේ නැති වෙයි. නියුට්‍රෝන්ස් වෙනස් කිව්වට, mass numbers වෙනස් කිව්වට කීයයි කියලා කියන්න වෙයි කියලා කිව්වේ. හරිද? right. හරි කියලා ඉන්නවා. term test එකට ආයෙත් ලියලා දානවා අර විදිහට. mass numbers are different, neutrons are different කියලා. right. හරි. So these are two standard questions. Then let's go ahead. තව පොඩ්ඩක් යන්න ඉස්සරහට. Now going to talk about showing atomic diagrams. And you can see one is like this, simple E here, simple P here. කොහොමද තියෙනවනේ? right. තේරුම් ගන්න යන්නේ. Page number 4 now. Let's start this table from the very last row. What is very last row? Standard representation, that means a standard form. H11, H12, H13. Let's go up from it. Mass number, atomic number, both 1 1. Second 1 2. Third 1 3. Can understand it? Yes. Then look at the top line. Name of isotope, isotope name. Protium, deuterium, tritium. ඒකත් හරිනේ. Now look at the atomic model. Look at the atomic model. Take one tut and come, practice us. Come on, it's okay. Take one tut and come. Your friends are here. Even both can come. You can put a chair and come. Both. तो chair का दागा. Come on, right? So our first diagram is like this. What is the meaning of this? Memane H11 no protium. Right, the protium. Protons 1. See, electrons also 1. Neutrons 0. Therefore, in this proton 1 we write by P. Don't have to put 1P, it is just P. Electrons 1 no, electron is here. Neutrons are absent. So we don't write simple N inside this. Diagram is that. Right? Deuterium now. Deuterium. Deuterium is H12. Protium nevi. Deuterium. Protons 1, electrons 1, neutrons 2 minus 1, 1. Therefore, in our diagram, proton 1 we write here, electron 1 there, neutron 1 this way. Last one, tritium. Tritium is H13, protons, electrons 1, 1, neutrons 2 minus 1, neutrons 2. How to mark it? Proton 1 here, electron 1 there, neutrons 2, we put 2n. This way we can draw atomic diagrams for isotopes. It's simple. And one more thing, electrons we don't have to mark here like 1 o'clock, 2 o'clock. Usually when there is one electron, this is the place for electron. I really don't know why is our textbook giving electron there. In all our diagrams, electrons we mark here top, but I gave as given in the textbook, but usually we mark first electron here. If there is one more, we mark that one here second. That is a standard way. Hurry, but it is just simple representation. Got it? This way, hydrogen's isotopes we can show. Chlorine's isotopes, two diagrams are there. Can you carefully look at it? Can you fill all the blanks? There are how many blanks? Total 6? No. Total 10 blanks are there. Can you fill all? All 10 blanks. Can you fill all 10? What do you had today? Karate. Karate. But she didn't go. No. Same school name? But karate cannot beat science, ne? So better you come science class. Hari, there are 10 blanks. Blanks 10ක් තියෙනවා. බලන්න පුළුවන්ද කියලා. සිතුලි. නෙතුලි. වයි නෙතුලිද සිතුලිද? නම් මොකද්ද? දෙකම වැරදි. මේ ස්කූල් එකේ මේ හරිය කරලා තියෙන්නේ. එහෙනම් සපෝට් එකක් තියෙනවා නේ. නැත්තම් මොකුත් තේරෙන්නේ නැති. බලමුකෝ. Right. First one, chlorine 1735. This way, 2 electrons, 8 electrons, 7 electrons are there. Total 17. Of course, total should be 17. And according to this, you can, protons and electrons both are equal and 17. You know that, ne? Right. So, electrons equals 17, protons equals 17, neutrons equals 35 minus 17, 18. Inside atom also you should write 17 protons and 18 neutrons. Now complete. Complete. What's the name of this? You don't need. You don't need. Did you get tute? Yes. Got the tute. Second one, chlorine, 37 here. The neutrons become electrons, protons 17, no change. Neutrons 37 minus 17, 20. Therefore, here also you have write 20 neutrons. Right, complete. So, these isotopes making things unclear, not sure. When we say hydrogen, there can be one of these three, right? There should be one when we say hydrogen, there should be one when we say oxygen, but there are three types. When there are several types of atoms, next concept bonds there. What is next concept? Percentage abundance. When there are several isotopes, this next thing is important. What is it? Percentage abundance. So, what is percentage abundance? Simply this. Look at this. Say we take 100 hydrogen atoms, 100 ganno hydrogen atoms, 100 H2 we take, and we find how much out of 100 is H11, how much is H12 out of 100, how much is H13 out of 100. This is called percentage abundance. We get H11 about 99.98 out of 100. We get this one 0.01, 0.01. The total is 100. So, percentage abundance means when you take randomly 100, how much is each as a percentage is called percentage abundance. තේරුණාද? random විදියට 100 දරම් බැලුවොත් මෙයා කීයද? අරයා කීයද? අනිත් එක්කෙනා කීයද? Percentage abundance කියනවා. So, you don't have to remember, though I wrote these values, you don't have to remember how much is each type. You don't need. But you should remember what is, which one is most abundant. That means when we say hydrogen, which one is there? Yeah. What is the most abundant hydrogen type? Protium. ඒතර අපි hydrogen කියද්දි ගොඩක් වෙලාවට කවද mean වෙන්නේ protium. ඔයා තමයි හැම තැනම ඉන්නේ. හරිද? එහෙනම් you don't have to remember how much is each, but you have to remember who is most abundant. Right. Percentage abundance is that. Percentage abundance of an isotope. Ready to read? Take your highlight also. Isotopes are found in different percentages, amounts, as a mixture. For instance, chlorine 17, 35 and 37 are found as 75 molecules and 25 molecules if we take 100 molecules of chlorine gas. Therefore, percentage abundance of first isotope is 75% and that of second is 25%. Right. I wanted to highlight then out of 37 and 35, which one? 35. May then again highlight first one, chlorine 35. When we say chlorine, say you get a call from home and said, daughter and son, chlorine came home. There are two chlorines, no? Which one has come? 35 mostly. Interval එකේ කෝල් එකක් කරනවා. කියනවා මේ පුතා මේ හයිඩ්‍රජන් ආව ගෙදර ඔයාව බලන්න. කොයි හයිඩ්‍රජන් ද ඇවිත් තියෙන්නේ? H1 1 එන්න ඇත්තේ. නැත්නම් කියනවා කෝල් එකක් දීලා කියනවා ඔක්සිජන් ආව ඔයාව බලන්න ගෙදරට. Which oxygen came? The most abundant one. So you should know which one is that. Simple. Hari. Right. Now about hydrogen and oxygen. If we take 100 molecules of hydrogen gas, 99.98% is protium, 0.01 deuterium and 0.01 tritium. So highlight protium. The most abundant is protium. ඔහොම අහනවා term test වල O level වල. Which one of the isotope given below is most abundant? H11, H12, H13, H14. එහෙම කෙනෙක් ඇත්තෙත් නැහැ උනට දෙන්න පුළුවන්. H11 is the most abundant. Right. Last one. Naturally occurring oxygen is composed of three stable isotopes: O8, 18, O8, 16, 17, 18. O8, 16 is the most abundant, 99.762%. Highlight O8, 16. Highlight O8, 16. O8, 16. Highlight current O8, 16. හරිද? right. හරිනේ. Now once again I am telling you percentages you don't try to remember. Remember what is most abundant. හරිද? right. මේ දොන්න සයන්ස් වලට මාක්ස් ගන්නවා සමහරු ක්ලාස් එකේ. සමහරු ගන්නවා 75%. සමහරු ගන්නවා 25%. ඕනේ නැහැ. කීයක් ගත්තද අපි මතක තියාගන්නේ කවුද වැඩියෙන් ගත්තේ කවුද වැඩ්ඩා. හරි අපි 75% ඕනේ නැහැ. මෙයා තමයි වැඩියෙන් ගත්තේ මාක්ස්. එයයි ඕනේ අපිට නේ. right like that. Which isotope is most abundant? Remember. So highlighted protium, yes. Highlighted chlorine 1735, yes. And highlighted oxygen 816, yes. Then next steps 1, 2, 3 you really need when you answer past papers next week. Okay, O-level paper and term test paper will give you diagrams of 4 atoms or a table with details of atom A, atom B, atom C, atom D, say atom E, and will ask you to select which one out of 1, 2, 3, 4 A, B, C, D, E are isotopes. හරිද? මෙහෙම diagrams වගේක් දෙයි. A, B, C, D, E අහයි. Isotopes are A and B, A and C, B and C, A, B, C. ඔහොම ඒ. නැත්නම් tables say A, B, C, D, E, protons, electrons, neutrons, this much, this much, this much. We'll ask you to find isotopes. Then you really need these steps. You know, if they are isotopes, one thing must be equal. What is it? One thing must be equal. What is it? This one and this one should be equal. Otherwise, they can't be isotopes. Hari, can you consider this one and this one as isotopes? No, never. Why? Same element should be, atomic number should be same, proton should be same. So very first thing is we check whether exam day you get this one and this one, and they ask you to find isotopes. Say A, B, C. What do you first check? What do you check first? Proton should be equal. 17 possible, 16 impossible. Right. So our first step is, how do we find isotopes using diagrams or information given? There should be at least 2 or more. Cannot think about isotopes if there is only one atom. I included this step because some students bring a diagram to me. Arang enawa diagram mega. Say this diagram. And ask me, sir, how can we find whether this is an isotope? ඕන් ඇටම් එකක් උස්සගෙනනවා. ඇවිල්ලා අහනවා සර් මේක මේ ඇටම් එක isotop එකක් කියලා කොහොමද හොයන්නේ? Can we find isotopes using one atom? Yeah. It's like someone points you, boy, girl. ඒකලා අහනවා, sir, is this a couple? Couple? How do we know? Couple නම් දෙන්නෙක්වත් ඉන්න බෑ. ඔන්න දෙන්නෙක් එකට හිටියොත් නම් අහන්න පුළුවන්. අර දෙන්න couple එකක්ද? We can do something. හොයලා බලතයිනේ. එක්කෙනෙක් බලලා අහනවා. Is he a couple? Is she a couple? Can we find? එහෙම බෑනේ. දෙන්නෙක්වත් ඉන්න ඕනනේ. Like that, don't bring me an atom and ask, sir, is this atom an isotope? Bad. There should be 2 or more than 2. right? And there should be, don't think සමහරු කරනවා තේරෙනවා සිංහලෙන් කියන සමහරු ඇටම් එකක් දිහා බලාගෙන දත් මිටි කාගෙන try කරනවා ඒක අයිසෝටෝප් එකක්ද කියලා හොයන්න. එකකින් හොයන්න බෑ දෙකක්වත් ඕනේ. හරි? right. That's the first one. You try කරනවා සමහරු ඒක. in the steps තියෙනවා for you. There should be at least 2 or more. Cannot think about isotopes if there is only one atom. හරිද? right. හරි. ඔන්න now we got 2 or 3 atoms or 2 or 3 or many atoms like this. හිතන්නකෝ මෙයා ඔන්න 3 දෙනෙක් ඉන්නවා. Then second step. First we check protons or atomic number. Proton should be equal in them. 8 හරි. මේ සෙට් එකම ගමු අපි ඔන්න protons check කරනවා. 8 17 17 16 11. Which can be isotopes? 17 17. අනිත් අය isotopes වෙන්නේ නැහැ. Atomic number should be same, right? First we check not mass number. Some students do the other way. Some students check mass number first. ඒක ලායෙත් හිර වෙනවා. Mass number නෙවෙයි 16 35 37 32 23 නෙවෙයි. You check atomic number. 8 11. No, not isotopes. 17. No, not isotopes. 17. Now 17 can be isotopes. 16. No, not isotopes. Right. Thirdly, finally, then we check neutrons. Mass number, neutron should be different or mass number should be different. Yes, then me දෙන්නගේ බලනවා mass number equal than at the no mass numbers different. That means neutrons are different, they are isotopes. So we conclude that out of 1 2 3 4 5 isotopes are 3 and 5. Got it? Right, we practice it next time because all our papers are in part 2. For that you can put 1 star here and remember this is how we find isotopes. This is how we find isotopes. හරිද මේ ස්ටෙප්ස් වලට දරුවක් දාගමු. ඕමයි අපි හොයාගන්නේ. Isotopes. Right. Then we have something simple. ඔය simple එක එහෙම කරලා තා චුට්ටක් කරලා we can take break. After break we do a little and then we do physics. Or we do physics and we come to this one. අපි interval එකෙන් පස්සේ unit 2 past papers ටික ඉවර කරනවා. හරි? ඉවර කරනවා. ඒක unit 2 එක physics. This is unit 3, this is chemistry. Right. Our next thing, electronic configuration, is something you already heard today. Electronic configuration. London syllabus Edexcel uses the word electronic structure for this. But O level our syllabus electronic configuration. I told you that when electrons fill into an atom, first electron and second electron come to which shell? Second shell, like here. If there are more electrons, they go to second shell. 1 or 2 or 3 or 5 or 6 or 7 or maximum 8. Ne? 8. If there are more electrons, electrons come to third shell. Maximum there can be 18, but usually there are 8. This way, electronic configuration means writing how many electrons are there in respective energy levels starting from the first one. Electronic configuration of this one is 2 in the first shell, separate by comma, 8 in the next shell, separate by a comma, 7 in the next shell. Writing electron arrangement this way is called electronic configuration. This method is completely wrong when you do A-level chemistry. A-level chemistry will introduce you some more locations in first shell. S, P, D, F කීකේ වැඩ ගොඩක් තියෙනවා. මෙහෙම ලියුවොත් සම්පූර්ණයෙන් A level වලට වැරදි. But if you write that method, completely wrong for O levels. O level method is this. Right? Arrangement of electrons is like this. Then usually in our class, the first student sits in the last row. නේ සාමාන්‍යයෙන් සමහරු දුවගෙන යනවා ක්ලාස් එකට. පස්සේ පෙළිය මුල් අල්ල ගන්න. නේ? එහෙම atoms වල එහෙම නැහැ. First electron comes to the first row here. First, second, third, fourth, fifth student, second shell, 6, 7, 8. ඔහොම යන්නේ. Ninth one, third shell. ඔහොම යන්නේ. atoms වල අපේ ක්ලාස් එකේ නම් එහෙම නැහැ ඉතින්. නේ දුවගෙන යනවා සමහරු උදේම ඇවිල්ලා පස්සේ කෙලවර අල්ල ගන්නවා. එහෙම දිනනවා ක්ලාසස් වල. එක්ස්ට්‍රා ක්ලාස් වල එහෙම දිනනවා. ඉස්සෙල්ලාම එන්නේ අතර මුල්ලට යන්නේ. අර සිල් සමාදන් වෙද්දිත් එහෙමයි බණ අහද්දිත් නේ. දුවගෙන ඉල බිත්තියට හේතු වෙන්න පුළුවන් තැනක සෙට් වෙනවා ඉස්සෙල්ලාම. හරි. ඔන්න ෆස්ට් ඉලෙක්ට්‍රෝන. බිත්තියට හේතු වුණා. සෙකන්ඩ් ඉලෙක්ට්‍රෝන තව කොහේ හරි හේතු වෙනවා. like that. But atoms not like that. First two electrons, first shell, third electron up to 10th electron, 11 to 18, third. This is called electronic configuration, right? So don't worry, you don't have to by heart this long definition. What is electronic configuration? It won't come. You will have to write electronic configuration like this for exams, right? කටපාඩම් කරන්න එපා මේ sentences ටික ඒ වහන්නේ. මේ විදිහට ලියන්නයි කියන්නේ. Right, electronic configuration. Electronic configuration is don't highlight, no stars, don't remember words. Representing how electrons are filled in the respective energy levels from the one nearest to the nucleus of an atom and outwards. Got the idea? Enough. Don't by heart. Even you can take your pen and cut first question and answer. Otherwise, I know what happens. Day before term test and O level, you try to memorize these definitions and they never come. නේද විභාගයට කලින් දවසේ පණ දාගෙන මේ ඔක්කොම කටපාඩම් කරගෙන ඊළඟ දවසේ ගියාම අහන්න එකක්වත්. ඉතින් ඉවරයි. Right. Second one, how to write electronic configuration, you know. Yeah, how? Find the total number of electrons present in the atom or ion. Ions are the atoms with a charge. So you need total electrons. Then put first 2 electrons into first shell, next 8 electrons to second shell, next 8 to third shell and rest to fourth shell. Separate shells using comma mark. මෙන්න මෙහෙම දිස්වේ නේ. මෙහෙම ලියන්නලු. හරි. Exercise. Write electronic configurations of following elements and ions. Can you try few? Like 1 to 8? 1 to 8 easy. Can you try 1 to 8? You are welcome to make mistakes. By mistakes you can remember long time. වැරදි කරන්න ඉඩ තියෙනවා. අවසර තියෙනවා. වැරදි කරන තරමට ගොඩක් කල් මතකෙ ඉන්නවා. හරි. 1 to 8 try කරමු. නියමයිනේ. ෆෑන් එක කරගෙද්දි ඇනුමක් එහෙම ඇරියොත් මෙහෙම ගියා ඇඟිලි ටික. dangerous fans නේ. හොඳ ඇනුමක් එහෙම ඇරියොත් ෆෑන් එක දා ගියා ගැලින්ම ඇඟිලි ටික. Dimatu mic වැඩයි. මෙයා නම් හොඳයි අර කලින් සමහරව ඉන්නකොට සමහර ක්ලාසස් වල ඔන්ලයින් පැයක් විතර වොයිස් එක නැහැ. පැයක් විතර වොයිස් එක රෙකෝඩ් වෙලා නැහැ මොනවා හරි සිග්නල් ඉෂුව එකක්. මෙයා ඉද්දි නම් එහෙම වෙලා නැහැ. Our online students know. Sometimes 1 hour, sometimes 30 minutes voice no. One to 8 easy, try. Last 4 little difficult but can. We will work about 15 minutes more and we take our break, right? Okay. Lithium contains 3 electrons. Lithium contains about 3 electrons. So how can you write 3 electrons in the first shell 2 and next one has to go to next shell? Boron 5 electrons. Out of 5, 2 in the first shell, balance is 3, 3 in the next shell. Nani? Oh, lithium 3 hari. Boron 5, 3 in the next shell. Right. Boron. Okay, first shell maximum 2. Then oxygen 8, 2 in the first shell, balance is 6, 6 in the next shell. Hydrogen 1, so we write 1, but there should be 2 electrons in the first shell. No, maximum 2. I told you, no, 1 or 2, but not more than 2. 1 in the blue one, 2 in the back. 1, right. Neon 10 electrons, 2 in the first shell, 8 in the next shell, 10. Can be 8, no issue. Calcium 20 electrons, 20, total 20. 2 in the first shell, 8 in the next shell. What is the balance? 10 more. Third shell can keep 10, told you, but usually 8 only there. 8 only there. We are studying the nature here. Nature is this, not 10 here. 2882 is calcium. 2882. That's why I wrote here, even though space is for 18, usually 8. These are maximum numbers, usually 8. Calcium. Right. Then nitrogen 7, 2, 5 makes it 7. Then magnesium 12. Magnesium 12, 2, 8, 2, 12. Right. After this, it is little doubtful. Calcium ion. You don't know what calcium ion is. Later you are going to learn. Next day, calcium is 2882. Calcium removes these 2 electrons, and because of removing electrons, calcium atom becomes calcium 2 plus. These electrons are left. How many electrons? 18. That's why it's given here. 18 electrons are there. But you don't need this story. What you need is how many electrons are there. This story you are going to learn later, but you don't need it. You need is what? How many electrons are there? How many electrons are there? 18. So 18 electrons must be 2, 8, 8. Oxide ion. The story is this, but you don't need it today, but I am telling you. Oxygen is 2, 6. Oxygen takes 2 electrons to the outer shell and it becomes oxide. How many electrons? After taking 2, 8. 2, 8. I have given you it. Oxygen has 10 electrons. 10 electrons means 2, 8. This story you can learn next time and in unit 10. For the moment, using electrons you can write. Magnesium 2 plus ion. Look at this. Magnesium is 2, 8, 2. These 2 electrons are donated by magnesium to become magnesium 2 plus. Then how many electrons are there? 10 electrons only. That's why I have given 10 electrons. 10 electrons 2, 8. 10 electrons 2, 8. Right. Then chloride ion. Chloride ion. This chlorine, which is 2, 8, 7, takes 1 electron, and this 17 becomes 18 then, and it is 2, 8, 8 here now. So anyway, 18 is 2, 8, 8. If you know electron number, you can write configuration. Right there? Okay. But maybe your school Madam Moser, maybe, has taught you to write something else other than this. Hurry. If you check internet, this answer is there. Some answers are with that. So which one is correct? First, shall I tell you what is that additional part? I don't say you should add it. I don't say, but I told you sometimes your Madam Moser has given me. Don't mark it. Maybe your Madam Moser has given you that it is Ca2 plus ne. So you should put bracket and write 2 plus. Kila samayata kiyanda. Oxide O2 minus ne. 2 minus. Magnesium 2 plus no. 2 plus. Last one, chloride. Negative no, negative. Maybe your Madam Moser has given this. Now which one is very correct? If you check textbook has never talked about electronic configuration of ions. Only atoms given. O-level papers, marking schemes never ask you to write configuration of ions. Only atoms came. So this is little additional. Therefore, exactly I can't tell you which one is correct. No evidence from textbook, no evidence from marking schemes. If you check internet, both methods are there. If you check A level, I told you completely these methods are wrong for levels, A levels. මෙහෙම නෙවෙයි ලියන්නේ. හෙන්න 아무තු විදිහ කරලා ලියන්න තියෙන්නේ. උත්තරයක් නැහැ. If they ask for levels, I think marks will be given for this definitely, and maybe marks for red color one also. Sure නැහැ. Internet එකෙත් මේ දෙවිදිහම තියෙනවා. According to our definition, O-level definition, it is an arrangement of electrons. It is not mentioning about charges. Therefore, black one is enough. I gave red one because if your Madam or sir has given, I have to describe it. Has your Madam or sir given this red color one? දීලා තියෙනවා නම් අත උස්සන්න. මං හිතන්නේ but දීලා තියෙනවද දන්නේ නැහැ. කාගේ හරි ස්කෝලේ කියලා දුන්නද එහෙම? නැහැ. සාමාන්‍යයෙන් ඕක කතා කරන්නේ නැහැ ස්කූල්ස් වල අයන්ස් කතා කරන්නේ නැහැ. ඒ බුක් එකෙත් නැහැනේ. බැරි වෙලා හරි දුන්නොත් කියලා මම දුන්නේ. හරිද? According to our definition, it is the arrangement of electrons, so black color one will be enough. But this one gives more details, but electronic configuration, our textbook method is this. So you don't have to put red color parts. Hari? Right. Now සමහර අය එහෙම අහලා තියෙන්න පුළුවන්. ඒකයි මම එහෙම කිව්වේ. කියන්න කියනවා. ඉස්කෝලේ එකේ දුන්නද මේව? දුන්නාද? බය වෙන්න එපා කියන්න. එහෙම දෙනවා. ඒකයි මම අහුවේ. දුන්නාද? ඔව් දීලා තියෙනවා. එහෙම දෙනවා. ඒ දෙකම අපි යූස් කරනවා. හරිද? ප්‍රශ්නයක් නැහැ. ඉන්ටර්නෙට් චෙක් කරොත් ওই දෙවිදිහම තියෙනවා. දෙකම හරි. Right? The difference is we are showing the charge here, we are not showing the charge here. Hari? But when you get this red color thing somewhere, you get more details because when you get only 2,8,8, 2,8,8 is actually argon also 2,8,8. When you write 2,8 only, 2,8 this one also. Hari? Petal you know. Therefore, sometimes we write these things. But electronic configuration means arrangement of electrons. Charges are not there. හරිද? තේරුණාද? දැන් අපි ලිව්වොත් 2,8 අපි දන්නේ නැහැ. මෙයාද දන්නෙත් නැහැනේ. ඒ නිසා මෙහෙම ලියනවා සමහර වෙලාවට. But electronic configuration can how many electrons are there. Therefore, black one is enough. තේරුණාද? If sometimes we give that charge also, I also give, it is to get you more detail. That means it is not only 2,8. 2,8 is this one, no? 2,8 this neon. This 2,8 is not neon. It has 2 plus. That means it is something else. හරිද? එහෙම වෙලාවකට දෙනවා. But normal electronic configuration is that's. මම කිව්වා. If this came for O levels, your answer can be 2,8,8 slash 2,8,8 this one. ඔය දෙකම හරිනම් එන්න ඕනේ. හරිද? So I don't think that they are going to ask because they have not given in textbook, but sometimes out of textbook things also comes. You know, සමහර වෙලාවට එනවා. So that's why I do it in class. හරියටම කියන්න බෑ මේකමයි හරි කියලායි බුක් එකේ නැහැ. කවදාවත් ඔය දෙස අහලා නැහැ. මාකින් ස්කීම් එක දැකලා නැහැ. ඒ කියන්න බෑ හරියට මේ දෙකෙන් මේක ලියන්න කියලා. ආව දවසට කියන්න පුළුවන් මේක තමයි හරියටම හරි කියලා. නේ? ඉතින් A levels වලින් කියන්න බෑද? A levels වල සම්පූර්ණ මෙතඩ් එක වෙනස්නේ. මේව ඇත්තෙම නැහැනේ. නැත්තම් කියන්න පුළුවන් when you do A levels, නැත්තම් when you come to grade 11, this is the method. If you do A levels, this is the method. කියන්න පුළුවන් දැන් බෑයි. මේ ඔක්කොම වැරදි. Method is not this. Right. Now we do about 5 minutes or 10 minutes and we take our break. කමක් නැහැනේ. විනාඩි 5ක් විතර නම් break කරනවා. ඇයි දන්නවද? After break my plan is to do physics. That's why. break එකෙන් පස්සේ මම physics කරන්න යන්නේ. ඒ නිසා හොඳ තැනකට ඇවිල්ලා නවතින්න ඕන. Let's do little more. Page number 5 ලේසි දෙයක් විනාඩි 10ක් විතර කරමු. Right. Page number 5 first periodic table and then modern periodic table. On our labs, one of the walls, there should be a big chart with many English letters. Table is periodic table. First day, when we come to our school lab, this one takes our attention. පළවෙනි දවසේ lab එකට ගිය ගමන් මේක අපේ ඇස් දෙක ටික වෙලාවකට උදුර ගන්නවා. ඒක දිහා බලන් හිතනවා මොනවද මේ periodic table. But luckily, we don't need that big periodic table. We don't need this big periodic table We need only a baby periodic table for O levels. අපේ O levels වලට තියෙන්නේ periodic table චූටි පැටියෙක්. චූටි පැටියෙක් ඉන්නේ මෙන්න මෙච්චරයි. There are only 20 elements. Other than these 20 elements, we need about 5 more elements for science. We need gold, which is not here, silver, platinum, copper, iron we need, but not here. ඔන්න ඔය තව 4-5 දෙනෙක් ඕන වෙනවා. හරි? Right. So this periodic table is the new periodic table. But before that there was a first periodic table. We talk about that taking 2-3 minutes. First periodic table had about 60 elements. Modern periodic table, according to your textbook, above 115. 115ට වැඩිය වැඩිලු. ඉතින් වැඩි කිව්වම කීයක් වෙයිද දන්නේ 1000ක් වෙයිද දන්නේ නැහනේ. ඔය 118 20 වගේ තියෙනවා. But our first periodic table had about 60. Why about කියන්නේ? Founder of this first periodic table, Dmitry Mendeleev, constructed this periodic table with blank places. Now sometimes when you sit here, you are keeping blank chairs between you and your friend. Why? Another friend is coming, another friend would come. Sure නෑ ඒද කියලා. කොහොරත් පුටුවක් තියාගන්නවා නේ. Like that, Dmitry Mendeleev couldn't find all the elements. Therefore, he found some elements and made the periodic table with blank places. Therefore, we say about 60. 60ක් විතර කියලා කියනවා. And when he arranged these elements, what was the reason for placing the first element as the first place? Second element after that. There should be a reason, no? ඇයි මෙයා ඉස්සෙල්ලම ඉන්නේ? ඇයි අරයා දෙවනි? There should be a reason. His reason was increasing atomic masses. Increasing atomic masses. Again, according to increasing atomic mass, he ordered elements. Hari බර අඩුම එක්කෙනා ඉස්සෙල්ලා. බර ටිකක් වැඩි එක්කෙනා ඊළඟ එක්කෙනා ඔහොමලු හැදුවේ. එතකොට who is the founder? Dmitry Mendeleev. How many elements were there? 60, about 60. What was the reason for ordering elements? Increasing atomic mass, lightest one to heaviest one. Right, that much is enough for this one. A small doubt is there. Once again, when we write the name of the scientist Dmitry Mendeleev, our new syllabus first printed book gave spellings this way: Dimitri, D-I-M-I-T-H-R-I, Dimitri was there. It was wrong. Newly printed books have it correctly. D-M-I-T-R-I, Dimitri කියලා තියෙනවා. ඒක නම් හරි. But still Mendeleev is wrong. Mendeleev තාම හදලා නැහැ. Mendeleev, when we write, if you check internet, the last letter is V, not F. But our textbook double F. අපි ඉතින් ඒ විදිහට ගමු. නැත්තම් වැරදි දැම්මොත් එහෙමනේ. Dmitry Mendeleev. Right. So, first successful periodic table was found by Dmitry Mendeleev. D-M-I-T-R-I, okay. Mendeleev, right, finally, double F. I have given you blank. Right there, FF. හොයාගත්තද කොහෙ ලියයිද දන්නේ නැහැ. අන්තිම blank එකේ double F ලියන්න. Dmitry Mendeleev. Right. And highlight this name Dmitry Mendeleev for MCQ can come. ඔයාලා දන්නවනේ උදේම පටන් ගත්ත ක්ලාසස් තියෙනවා මේ අපේ ඉන්ස්ටිටියුට් එකේ උදේ 7ට 7:00ට වගේ. ඒගොල්ලෝ ඉන්ටර්වල් දෙනවා 10:10:00 වගේ. ඒතර පොඩ්ඩක් ඉතින් washrooms වල canteen වල පොඩි තදබදයක් තියෙනවා. හරි. අපි ඒක පොඩ්ඩක් සික් කරලා දෙමු. එතකොට අපි free. හරි ඔයාලට ලේසි. නැත්තම් washroom එකේ ගියාම එන බෝලි. canteen එකෙත් එහෙමයි. පොඩ්ඩක් ඒක මගේ අරලා දෙමු. එතකොට හරිය. right. තව විනාඩි 5කින් වයි ගමු. Right. Then first successful periodic table was found by Dmitry Mendeleev. It was produced by ordering elements based on the ascending order of atomic mass. Highlight Dmitry Mendeleev, highlight ascending order of atomic mass. Ascending order of atomic mass. Right, third one. There were about 60 elements in it. Highlight about 60. 60ක් විතර. with empty positions for unfound elements. Highlight about 60. Right, empty positions so තිබ්බල හොයාගත්තේ නැති අයට. Right, then modern periodic table. We take this introduction and we finish. Modern periodic table. As I told you, you all have to remember first 20 elements in modern periodic table. There are various poems for that, various songs for that. If you are using something already, please don't change it, you use it. Or still I am using my grade 7 or 8 science class madam's poem. Samare vata. For some others I am using my A level tuition classes poem. Like that, if you are using something, don't change it. If you don't have any poem or song or something, you can use this one. තේරුණාද? ඔයාලා දැනට මේක පාඩම් අය ඒ විදිහටම යන්න වෙනස් කරන්න ඕනේ නැහැ. හරි දේ වෙනස් කරන්න ඕනේ නැහැ. පොයම් එකක් කරන් මම නැත්තම් මෙන්න මේක අල්ල ගන්න. හරි? right. Right. So hydrogen is not in my poem. Second line has a poem. Right. Give me a name of someone with NE. NE වලින් පටන් ගන්න නමක් කියන්න. දැන් yesterday Tuesday class there was Nathan in the class. So අපි Nathan නෝ ගත්තා. මේකෙත් කවුරු හරි ඉන්නවද? NE. හරි අපි තමු ක්ලාස් එකේ ඉන්නවා කියලා නිකන් නෙතුලි ඉන්නවා කියමු ඈ දැන් එයා දිහා කට්ටියම බැලුවින්ද එයාගේ නම ගන්න නැතුව ඉමු පවුනේ මේ අපි එමු ක්ලාස් එකේ නෙතුලි කෙනෙක් ඉන්නවා කියලා නැත්තම් නේතන් නැත්තම් නෙතාර හරි කවුරු හරි නෙතුලි කියමු ඈ හරි නෙතුලි හරි අපි නෙතුලට කියනවා නෙතුලට කියන්නේ නෙතුලි ඥානි ක්ලාස් එකේ listen BBC news on Friday නෙතුලි කියලා කියනවා හෙටයි කියන්නේ හෙට BBC news අහන්න කියනවා. මොකද කියන්නේ? listen BBC news on Friday නෙතුලි. හරි? listen BBC news දැන් මොලුවට ගන්න now. මොකද කියන්නේ? listen Reuters news නෑ Reuters නෙවෙයි එහෙනම් Al Jazeera නෑ BBC news. listen BBC news on Friday නෙතුලි. ඔලුවට ගියාද? recorded listen BBC news on Friday නෙතුලි. හරි. එහෙම ලියනවා. මෙන්න listen BBC news on Friday නෙතුලි කියලා කියනවා. Helium is here on the top of this. හරි. What did we use? If you don't have anything, listen BBC capital simple ඕනේ news on Friday නෙතුලි hari Niels Bohr hari Nathan hari something, right? Then in one day there was a girl in the class called Lisa. ඉතින් ලීසා ඉන්නවා කියලා යාළුවෝ ටික මෙහෙම එකක් හදලා තිබ්බා. මොකද්ද? ලීසාගේ බෙල්ල බල්ලා කාලා. නංගි ඔයා ෆයින් නේද? what? ලීසා බල්ලගේ බෙල්ල කාලා. නෑ. ලීසාගේ බෙල්ල බල්ලා කාලා. නංගි ඔයා ෆයින් නේද? ඔය මොනවාරි හදාගත්ත හැකි. හරි? I think be careful when you write BBC news so බෙල්ල බල්ලා කාලා. මේක නම් හරි මේ බෙල්ල බල්ලා කාලා. දැන් BBC news sometimes බල්ලගේ බෙල්ල කාලා වෙනවානේ. BBC news නේ. හරි. බෙල්ල බල්ලා කාලා. කැමති එක. මොකක් හරි ඈ. හොඳට බෙල්ල කාලා තියෙන්නේ. හරි. හරි. Something like that you can note there, and using that you have to practice this. Otherwise it can be ballage bella kala. B can come here, BE can go there. Be careful. And carbon and chlorine also sometimes confusing. Hurry. For the next one, I still remember what my A level sir said, and I had to change it because it's for A level students. Little dirty things are okay, and the O level students, right? A level students ට පොඩ්ඩක් අනම්මනම් කිව්වට අවුලක් නැහැ. O level 10 වසරයට එහෙම බෑනේ. වැදගත් දේවල් ආයෙම කියන්න ඕන. හරි. මෙහෙම කියනවා. You know sometimes when we are home alone. අපි ගෙදර තනියම ඉද්දි නේ we want to do, including me, we want to do everything which our parents don't allow us to do. මේ අම්මලා තාත්තලා කරන්න එපා කියනවා ඔක්කොම ටික කරනවා ගෙදර කවුරුත් නැත්තම්. හරි. So one day a small ayya and very small nangi left home alone. Hari, they wanted to eat everything and they could find only sugar bottle. Who found? Nangi found. Now Ayya wants to eat. So Ayya is telling Nangi, Nangi mage allata seeni purawanna sudu kelle ane. Nangira padi part එකක් දාන අනේ සුදු කෙල්ලේ මගේ අල්ලට සීනි පුරවන්න කියලා කියනවා. හරි? So ඕක තමයි අපේ better version නේ. Bad versions are there, very bad versions are there. කියන්න බැරි poems උත් තියෙනවා. Right. Okay. අපි එහෙම ගමු. නංගි මගේ අල්ලට ගුටියක් දෙන්නද? නෑ. හරි. සීනි පුරවන්න බෑ කියනවා නංගි. සුදු කෙල්ලේ අනේ කියලා කියනවා. ආනේ කියලා කියනවා. හරි. ඒ ආරේ. Can you use something? Right, then potassium, calcium. So if you don't have any poem or song or something, you please note this and use. If you are having something, don't change it. Somehow you should be able to write 20 correctly. Right. මෙතනදී යන්න දෙනවා. This was it. ඕන එලියා ගන්න. This one is used in many schools also, so I can give no issue. ආනේ කියලා ලියමු. We are giving online also, no recorded, no bad දේවල් දෙන්නත් බෑ. හොඳ ඒවා තමයි දෙන්නේ. හරි. If you are using something, please use that, don't change. If you don't have any method, use this one, right? Now itself remember, listen BBC News on Friday Netuli. Is there, right? So somehow you should be able to write these correctly. Hari. So I want you to note those things and fill these on page number. What's the next page? Next page has an empty table, blank table. Fill it quickly. දැන් නම් ඉතින් අල්ලට සීනි පුරවන්න නෙවෙයි බඩට කෑම පුරවන්න තමයි බඩගිනිනේ. After interval, as we are going to do physics, I have to bring you to a good point and a stop. To be continued later. And if we can complete this page and a stop, it takes very few more minutes. Then we are parallel to Saturday class, very close to Saturday class. And after finishing physics, we can continue from here. Now other continue करते हैं. Right. Please fill these quickly on that table. Right. Then come back to our original page, modern periodic table. Wanna listen carefully. Modern periodic table has been made by many scientists. Contributions are there. What is the reason for ordering these elements this way? Why is hydrogen first, helium next? Why is lithium, beryllium in that order? Modern periodic table has been constructed using two factors. One is ascending atomic number. Atomic number is increasing one by one, and where to write atomic number? Left hand side down. So I want you to put left hand side down. But left hand side down, දකුණු පැත්තේ එහෙම ලියන්න බෑ. වම් පැත්තේ පල්ලෙහා. Put numbers with me 1 to 20. On original one, and in that one also you can do 4 down numbers 5 6. If you have to find atomic number of any element, you can write periodic table fast there, and you can find atomic number if you know this. 16 17 18 19 20 atomic numbers. Right, තව විනාඩි 5ක් වත් ගන්න වෙයි. ඊට පස්සේ අපි ඉවරයක් කරමු. Right. Put atomic numbers 1 to 20 එක දිගට දාගෙන යන්න. Atomic numbers. Right, අපි මෙහෙම කරමු. Hungry faces, angry faces. We take the break now. Right? බඩගින්න මුකුත් කරන්න බෑනේ. we have learned here. So, let us take the break. After break, I leave this without erasing. On that board we can discuss some O level past papers. We finish it and get back to this one.